Good morning, everyone, to the last day of Blockchain Kaigi 2025. We all made it here. And today, for the first session on applications, I would like to invite Thilina Thushan from University of Sri Jayawardhanapura, who will be talking about vehicle record history, maintenance through blockchain technology, and fault prediction using AI/ML.
Good morning all. My name is Thilina Thushan. I am from University of Sri Jayawardhanapura, Sri Lanka. This is our research topic, vehicle record history maintenance through blockchain technology and faults prediction using AI and ML. These are the topics what I am planning to cover in this presentation. In introduction, let's talk about the global context. Many countries around the world have adopted digital vehicle registration systems to enhance transparency, security, and efficiency. These systems often use centralized databases which streamline registration but still come with key vulnerabilities. Data manipulation, cyber attacks, difficulty maintaining accurate tamper-proof histories. As vehicle market grows, maintaining a secure and reliable vehicle records has become a global necessity. In the Sri Lankan context, Sri Lanka's current vehicle registration system also uses a centralized system leading to fraudulent activities. Fraudulent activities compromise data integrity, such as altered histories, fake documents. Inefficiencies and inaccuracies in the current centralized vehicle record system, multiple disconnected stakeholders lead to delays, errors, and fraud. Data tampering. These are the research problem of our research. The centralized system issues, risk of fraud and data loss, no predictive mechanism for vehicle faults. Three core research questions are: how can blockchain improve security and transparency? How can AI/ML predict vehicle faults? How does this system compare to the current one in speed, accuracy, and trust? So why this system? This system provides secure, decentralized, tamper-proof vehicle records using Hyperledger Fabric. This ensures trust and transparency among RNV, which is Registry of Motor Vehicles, buyers, service centers, and insurance companies. This prevents fraud, document manipulation, and inaccuracies in histories. Integrate with AI/ML for early fault predictions, which supports preventive maintenance. This creates a single, unified platform connecting all the stakeholders. This improves efficiency, decision-making, and reliability in the vehicle ecosystem. So this is the literature review of the research. When we talk about global studies, Sanepera et al. Proposed a blockchain-based system to eliminate fraud and delays in the traditional vehicle registration systems. Hossain et al. Suggest a decentralized ledger for vehicle registration in Bangladesh to prevent cyber attacks and ownership disputes. Piana et al. Used machine learning models like random forest for predicting vehicle faults, improving diesel engine maintenance with AI. In the Sri Lankan context, through CARE, Samarakodi 2019, a blockchain-based system for secure vehicle history tracking using Ethereum network. Malinta et al. Proposed a blockchain for digitalizing RNV processes to enhance transparency but without predictive capabilities. So we identify these gaps. These existing systems lack of integration of AI/ML for predictive maintenance. Also limited real-time interaction between stakeholders such as Registry of Motor Vehicles, service centers, buyers, insurance companies, like that. No unified system that combines blockchain and AI/ML tailored for Sri Lanka's context. So this is our methodology. We use Hyperledger Fabric for our blockchain technology, which is a permissions blockchain platform to create a secure, decentralized vehicle records without transaction fees. For storage purposes, we use interplanetary file system for decentralized storage of large vehicle records such as vehicle registration certificates, which are stored in the IPFS. For the smart contracts, which automates vehicle registration and record updates, ensuring that only authorized parties can access or modify data. For the AI/ML model will be used to analyze historical vehicle data and predict potential faults. This is the system framework. We use Livewire for responsive UI for the front end, and also we use Laravel to handle authentication, smart contracts, and data interaction for the backend purposes. We also use MetaMask for blockchain transaction approvals. Suppose there is a transaction that user is a government party, so user need to store some data in the blockchain, but any other party, any other user, he can't save the data in the blockchain without MetaMask authentication. So this is the proposed system architecture. These are the actors of our system. Also, the actors which are in the government parties also need to authenticate via MetaMask. And this is the web application. It uses a machine learning model, random forest model, and the open AI model. Also, we use smart contracts, interplanetary file system, and the blockchain. This is the chain code design. Laravel backend communicate with the smart contract layer, which has these functions: create vehicle, get vehicle details, transfer vehicles, get vehicle histories. This is the machine learning model design. The blockchain ledger communicate with the and extract the data. Then it goes to the vehicle service dataset. Then we pre-process it and train the random forest model. Then the output of the random forest is a binary value. So we transfer random forest model's output as an input to the OpenAI model to translate the prediction to human readable format. So after that, this text is go to the front end and the reports as well. So data collection method, we use a Python script to generate a data set. Also training data set which has 100,000 samples with 75,000 for training and 25,000 for reserved for testing. For the input features, 30 features including both general vehicle informations and detailed service related indicators. Labels such as tire and alignment faults, engine faults, electrical system faults, brake faults, transmission faults, and AC faults. Also the coolant and air filter faults. These are the results and findings. Model overview. We use a random forest multi-label classification model. For the data set, we use 100,000 samples, 75,000 for training, 25,000 for testing purposes. We use 30 features such as service related and vehicle attributes. Also, we use 7 fault types labels. Training time is approximately 117 seconds. These are the key performance matrices. These are the challenges of our system. Multi-fault prediction, predicting various fault types such as engine, brake, electrical simultaneously was difficult. So we use a random forest multi-label classification model to support this challenge. Limited blockchain resources. At that time, we can't find any beginner-friendly tutorials for Hyperledger Fabric, so we relied on YouTube tutorials and the documentations. The lack of real-time dataset. It was difficult to find publicly available and relevant vehicle fault dataset. These are our future works. We are planning to improve in the machine learning model with real data. Replace manually generated dataset with real service data collected through the system. Regular model retraining, continuously update and retrain the random forest model using new service records from vehicle service centers, emission test centers. Provide selectable versions of the machine learning training data. So the goal is to provide a better accuracy and insights. So stay up to date with the real world fault patterns, improve fault predictions accuracy over the time, help users to take proactive maintenance decisions. As a conclusion, this system modernizing the vehicle management. This blockchain-based system enhances vehicle record security, transparency and efficiency in Sri Lanka, predictive capabilities with AI/ML. Vehicle owners, service centers can use AI/ML powered predictions to prevent faults, ensuring safer vehicles. Long-term benefits, this system set a new standard for vehicle record management, potentially expanding beyond the Sri Lanka. So thank you for your time and support. Also, you can find live project demonstration and more information using these websites. Thank you.
Thank you very much, Tilina. Do we have any questions?
So in your model, how are you thinking about the inaccuracy or incomplete data that could be provided by maintainers?
Yeah. In machine learning model, we try to solve the problem. So let's say there's a service center and the vehicles. The service center can use our systems to put their data. Let's say the engine oil is changed like that. So we use these kind of data to the data set apart from the vehicle normal details. So our random forest model uses that kind of service data to predict the vehicle's potential mechanical faults.
Interesting. And one more question. So are you thinking about implementing like a DAO-like system for your system, basically, where users can vote about what metrics should be included,
Yeah.
like as a part of this the major model that you're building, basically?
Yeah, at the current conditions, we don't try to do that. In the outline of the research is just
Right. Okay, you can maybe think about that.
yeah, as a future.
Great work. Thank you.
Thank you.
Questions? Let's thank the speaker again.
Thank you very much.
Thank you. The next presenter is Sivadas Nilima from Kerala University of Digital Sciences, Innovation and Technology. We'll be talking about fortifying donor privacy and enhancing accessibility in blood donation using ZKP.
Well, good morning, everyone. My name is Nilima. I'm from Kerala University of Digital Sciences, Innovation and Technology. I'm working as a research and development engineer, and I'm representing my organization and my team for this paper titled Fortifying Donor Privacy and Enhancing Accessibility for Blood Donation Using Zero Knowledge Proof Approach. So basically, the touch points in this discussion would be stretched from the problem, the related work, the methodology, the sneak preview of the application that we are proposing, and then the way forward. So we'll first come to the problem. So in the our problem is centered on this context of blood transfusion. As we all know, blood transfusion is a medical procedure of transmitting blood in the case of life-saving conditions like diseases, injuries, or even surgical procedures. So as per the WHO reports, there is a marked difference in accessibility of this blood to the population, and it is specifically towards the low income and high income countries. This difference is very much spiking. And also in India, as per the Press Information Bureau reports, it has also been stipulated that the demand for the blood transfusion arises for every 2 seconds, and the accessibility is also so drastically short that even though there is around 14.6 million blood needed every year, there is always a 1 million shortage. And this calls for, in light of recent events also where we have seen, there are lots of blood transmitted infections also prevailing about. So the donor retention is something which is very much crucial. And as per many of the reports, it's been found that the donor has a lot of concerns. Apart from the myths and misconceptions, there are lots of privacy-based concerns among the donors, and this sometimes and most often hinders the donor retention. So we are focusing on this aspect. So as we have said before, that the donor's dilemma is one of the key things that we are addressing here. That is, yes, as part of the screening procedures, the donor might require to reveal their name or their medical history and everything. But it is not at all required for the donor to share the location or the residential details, because that wouldn't come in any way with respect to asserting whether this donor is a rightful or a healthy donor. So we are addressing this particular problem. So now how do we resolve this? So to summarize it or to make it more simpler, we'll travel to a place called as River Mist. Now, basically, this is a story here. So River Mist is a place where there is a competition around, which is a treasure hunt competition. And this competition involves finding a treasure chest location. And the judges have informed the contestants that they have to find the treasure chest location, but they do not need to reveal the exact location, but they can just give a proof of where is it exactly. So this is a contestant who is Alice, who has found this location. And now how this Alice has found the location is that she has found a unique leaf, a golden leaf, which was attached to that treasure location, and she has just fetched it and come out. So just a disclaimer here, we may not be confusing here with the token written here. It is not the token that we usually speak in the blockchain concept. So this further portrays to this concept of this ZKPs. And in ZKPs, as we all know, that there are 3 fundamental principles. That is a completeness. In this context of the story, we can say that Alice has found the location because she has got the unique leaf token, which is attached to that treasure's location. And then she has been able to prove to the judges, and she has able to win the prize. So that fundamentally proves the completeness principle. When it comes to the soundness principle, it is about any kind of fraudulent contestant cannot now win this prize or win this contest, because unless and until they know the location, they will not be able to prove it. And that shows the fundamentalness of the ZKPs. Then we come to the third principle, that is the zero knowledge. The judges or nobody knows the exact location, because the only proof that they have is that the unique leaf token that Alice has got about. So this is all about the magic key, what we are saying about, and that is the ZKPs that we'll be using here. So these are few of the related works that we have found, which are somewhere in line with it. What we have observed is most of these are conceptual, or they are proposing or framework related. Empirical evaluations are quite limited in these works, and that's where we carry forwarded our ideas, and further we implemented it. So the methodology we approached is using the Plonk protocol, and the Plonk is one which is more, the highlights of this Plonk is that it is a universal. It has a universal and updatable circuit. That is, it's like just a template. So it is like irrespective of your use case, it can be anything. For example, it can be a voting app where you have to show your we can use your zero knowledge proof there, or we can use any other application, but it's just a template that has to be implemented. So that is a highlight of this Plonk-based approach. And also it can, the capabilities of the Plonk is such that it can handle multiple of the complex equations in a single circuit. The circuit is a place where we all perform this normal mathematical operations. So it is capable of handling very complex operations and the circuits. And that's the highlight of this Plonk-based approach. And that calls for its versatility for numerous applications. So the proposed system architecture, we have bifurcated into two parts. The first one is about the registration. So the registration happens here, right from the donor, who may be using an Android, and then we have the hospital who also will be registering. So the donor, first of all, when he registers, it's a one-time registration where the application requires the donor to capture the GPS location coordinates, so enter the coordinates. He or she might not be entering it. It will be the normal way of application capturing the location coordinates. It's the same way it will be capturing here also. And then this proof engine, the blockchain, will be storing the proof. So the proof will be generated by our specific Plonk-based mechanism here that we'll be discussing in the further slides. So that is the first stage, first part. And the second part is the request response overflow. In this the second stage, what happens is like whenever a donor request comes, so the hospital has listed their requests depending on their high or medium or low requirement. So urgency, that's the urgency. So the donor, whenever they come to a login again and they find that there is any requirement with respect to a hospital or a unit or a place, they usually take that information and they have this location confirmation whether they are close to the proximity or not. So that comes as the second time verification comes. So there are two proofs which are being performed here. One is the location, first primary proof involves the capturing of the location, and there we have this proof converted and stored in the blockchain. The secondary proof is the one which confirms the donor's close proximity to the location, and that further concludes that this donor is quite near to the location, and he can be or trusted enough to be accessible to get this blood. So this is the operational workflow design, as I mentioned before. First is the registration and location verification, the place where we have the primary proof generated here. And this is finally just the proof is stored on the blockchain, nothing else. And then further in the next way, we can see that the donor is further getting a request, and then the request is been further validated from the proofs on the blockchain. And there is a periodic in between. We can also see there is a periodic location confirmation where each time the donor logins into this application, this location coordinates are being captured, and then the proof is generated, and it's been stored in the blockchain, and it's been further, whenever the request comes, the latest location proof is being checked and then finally confirmed for whether the to assert that this donor can be given the appointment. So this is the tech stack here. As we have, as this is the whole architecture included here. So we have the UI, which is the front end given here. So we have the mobile application and the web application handled by the units, the hospital or other emergency units. Then we have the back end, which is being maintained by our Node.js, that is our Node.js thing. And then we have the blockchain and zero knowledge proofs, which has been generated by the privacy layer. The MongoDB database stores the initial details of this donor, that is a name or other details and everything. Then the smart contracts performs the deployment on the blockchain. Now, coming to this concept, I'll make it more simple for deciphering this thing. We can consider this as three components here. We have the privacy layer, then we have the blockchain layer, and then we have the front end layer. Now, privacy layer, we have this. We have performed this using this Neuer DSL, domain-specific language, which is on Rust-based syntax. So we have this Neuer.js, which is the main component where we generate, where we write the logic. I mean, where it's the first stage. And then what happens is there is a backend Mac proof engine which generates it, that is called as the bb.js, Barattenberg.js. Now this converts into a format called as ACIR, that is called as arithmetic circuit intermediate representation, which can be even used for any of the zero knowledge proof system for verification. Like we are suggesting here Plonk, it can be maybe for others also they are saying that it can be used. That's the documentation that says that. So once this is being done, next comes to the. So this particular Neuer.js is further compiled by the command line tool that is again supported by the Neuer DSL. That compilation is done by a command line tool called as Nargo. Now this Nargo generates a verifier.sol solidity file. Now this solidity file, along with the smart contracts that we have initially generated, gets totally deployed in blockchain, and the proof is generated there. The front end, the donor's browser, the donor's browser is being supported by this noir.js and the bb.js. These are the two libraries that will handle this particular GPS coordinates and location coordinates, and that will be stored in the browser of this donor itself. Only the proof will be transmitted towards the blockchain and for further verification. So this is the sneak preview of the application. We have the application running, and I'm happy to even share with you all after this maybe presentation, but considering the paucity of time, I had captured the screenshots for the benefit of the audience. So the first, at the leftmost corner, we can see that there are three components here: the hospital, the donor, and the admin. So we have the donor is a particular service provider who handles this, sets the anchor points, a particular location, and from that location, there is a radius also given here. Radius means the circumference, like from where the particular requirement comes along. So that is being set here. Now the donor is the one who registers here. So you can see here in the second screenshot here. So I've just entered the details. So the email and the mobile number is just optional. The blood group is essential, and then the city. So I had done this when I was staying back at my home place. So the city I have entered, and then the maximum radius, the radius within which the donor is located, that has been entered. But the latitude and the longitude is the one captured by the normal our GPS thing. So that is being done. So the registration is confirmed. Then the donor dashboard appears here. So as we know, only the public inputs, that is the public inputs here refers to the anchor point. The anchor point is a city where the place where the donor is quite near. So that is being there, and the distance is the one which the city has determined that within which the donor should be there to get the supply. And then we get and luckily what happens is, like, the donor has one request, maybe an immediate request, the medium request. So that is being available, so the donor can accept it because it is aligning with the blood group that donor has given. And then we can see at the rightmost part, the donation request comes. So the donation request may first, do you confirm the donation request? At this point of time, yes. So the first primary proof gets generated, and that is the one which takes further to the time slot, where the donor can select the time slot. So once the donors select the time slots, again the question comes, the system generates a question saying that, are you confirming this appointment? So at this time, it again takes a location, and then it confirms about the proximity, whether the donor is quite close to the application also. So primary proof and secondary proof. So, and then finally the appointment is confirmed. This is the view from the hospital side, or whatever the donation requests are available, and which is open or which is accepted already, and when it is created, and what is the urgency, whether it is low, medium, high. And this is the hospital side, or the unit who wants a blood supply. So they will be putting the details here. So this is the, already we have the POC here. So what it will be, a next step will be first going with the security auditing part. We have to look in, because again it's a proof-based system and everything, so we have to go with the security auditing. Then we will be again checking for regulatory compliance. More or less it is complying with the GDPR things, because we have only the proof here. And but still we will be going through the regulatory compliance requirements. And then we have the pilot launch. We have to tie up with a single partner, hospital or service, hospital or mobile bank, blood bank provider for evaluation, further evaluation. And final deployment will be there. That's the procedure we will be looking forward for the final launch pad. And this is finally what we try to propose through this idea, or through this concept, is these three pillars. That is, first is the business. First is about the business value is there, because definitely because of this regulatory compliant kind of proofs, these are already been established. I mean, the particular backend related circuit designs or system methods or tools are there, which has already been tested and formulated well. So we have lots of probability of getting a good business value from these methods. And this is a liability reduction is also there, because there is a resilient proof available here. Then we have technological superiority, because yes, this Splunk-based system offers universal scalability also. And again, a POC is a mobile friendly setup. There is an ease of experience also, because there is not much the user has to put stress about. And then we have, when we consider the social impact, we can consider that this also alleviates the concerns of the donor with respect to the privacy. At the same time, it also ensures that the hospital or the emergency or whichever the blood bank unit is there, they are also able to access blood, which is very important but timely. So that's all about my presentation. Thank you so much.
Thank you very much. Questions?
So, yeah, forgive me for not understanding ZKBs properly, but let's say your registrations happen once, right? When you're storing the location in the blockchain.
Yes.
Right. So if we have a donor in, let's say, one city and registration happen in city, let's say another city, and then later on that specific donor move to another city.
So there is
in
a
that
periodical location confirmation.
periodic, right, right.
It's not just one time, it's
not just-
periodic.
It's periodic as well. Okay. And just I had a question as a developer myself. So your mobile app is in WebView, or is it natively running?
No, it's in presently, we have put it in WebView.
Right. Okay. Thank you.
Yeah.
Any questions? I have two very short ones.
Yes.
Thank you for your presentation.
Yeah.
So your pilot testing that you were talking about, where do you plan to test it?
No, we are actually trying to, because this is like a real world evaluation is quite important. So we are looking forward to some hospital units or something whom we can initially tie up, and because we have to estimate, for example, I also missed to inform this thing, because we are doing some virtual evaluations, like we try to do the performance verification of the ZK proof. So around we try to run it around eight concurrent users. Like we were in 8 concurrent users over 30 seconds, we were able to achieve the process the request. API handling was perfectly working, and the proof verification time was around 221 milliseconds. But again, when it comes to real world situation, it changes, because the hospital's capacity, population size, like the capacity, beds, everything changes. So that has to be addressed, and that's how we are looking forward to.
Also, a follow-up question on that is, because I do not assume they will understand what they are actually testing, so do you plan to teach them or give some instructions on what blockchain is and what you are trying to do, and maybe perform a case study or kind of an interview on that?
Basically here, the hospital need not be much concerned, because as a service provider, we will be looking on to the most of the parts. Like, I mean, they have to just ensure, because definitely hospitals have a lot of things to look forward, and this is something which is, though it is very essential, we are trying to alleviate the hospital's concerns also, because we have this, the hospital just has to register once, and they have to just ensure whether whatever the request is being got, like, because they have to manage the screening part and everything. So here we are only concentrating about the location and the details things. So we are already giving a proof as such for them to ensure that whatever the donors or the accessibility to the donors is eased, and they're getting at the right time. So I think the hospital may not have to worry much about, I mean, compared to maybe other things, it might be just a pinch.
Thank you very much for the presentation. Let's give the, yes?
Oh. I have two questions actually.
Yeah.
Sorry, very brief. Thank you so much for that talk. Really nice. I have two questions. The first one, it's about the pre-screening. So I'm not quite sure I understand correctly, but is this donor have a physical interaction with the hospital?
No.
So how can the pre-screen of the blood donations conduct?
No, the pre-screen, we aren't involved in any of the pre-screening part, because that is something which has to be put by the donor themselves, and that has to be taken care in a different format. We are concentrating only on the proximity or the availability of the donor. So that has to be managed, or that has to be looked by the hospital themselves, because they have the expertise in handling it.
Right. So basically, in some sense, the donor have to upload it, for example, like certificate to say like they are kind of clean.
Yeah, it's just like they have to get, as we have the zero knowledge proof the proof to assert that they have their their proximity is verified. In the same way, they have to show something in order to ensure that they are in the healthy category, or they are completely averted like from any of the healthy any of the risks.
So in that sense, it's not like completely set like CKP.
Sorry?
So that is not completely like anonymized, right? Because of somehow you have to.
No, yeah, that's what we cannot. This cannot be completely anonymous. That's what our use case is completely focused on the location part, because this is something which is very sensitive. And as you like in India, for example, recently there are lots of news around, or cases around blood transmitted infections. And those are like which is like we cannot be avoiding it. And we have India has the largest burden of thalassemia also, which requires regular blood transfusions. So in that case, the medical history of all those aspects of the donors, that may not be inevitable to be avoided. So we have to concentrate. That's the reason we are concentrating only on the location aspect, and that's the ZKP that we are assuring about.
I see. So actually, this has come to my second question, because
Yes.
now you are focusing on the locations. How about the incentive? For example, like if you are now in the location where the blood is really highly needed, but no less donor, how about like incentive mechanism?
So actually, there are reports here. Actually, in India based, there are reports saying that incentive-based donors, again, they are also most probably they are really one that can be they have the most probable ones who give these infections. So incentivization here raises lots of concern. We are more focused on the voluntary blood donation.
Okay. Thank you.
Thank you.
Thank you very much, Nilima. I would like to invite the next speaker, Ashish Rajendra Sai. Will be presenting on quantifying developer centralization in blockchain open source ecosystems, analysis on GitHub repositories.
Should work. Thanks a lot. My name is Ashish. I'm an assistant professor at Maastricht University in the Netherlands. Despite the really long title of my presentation, I'm really just going to talk about decentralization. It's a topic I find really interesting. I have a few slides. A few years ago, I was working in UC Berkeley, and I had the opportunity to meet a lot of law people there, especially from the Californian government. And this is way back when the regulators were still trying to figure out how to regulate blockchain. So they had to come up with regulations, but they first had to define what a blockchain is. And it may seem trivial to us, we have seen definitions, but for law people, they really have to make it precise and measurable so they can actually apply it. And that's where they started talking about decentralization. And they really could not come up with one single definition of what a decentralized blockchain is. And I did quite some work on trying to formally define decentralization. You've all heard of Ripple. Ripple is currently in a case with the SEC in the US, where SEC is trying to classify Ripple as a particular type of asset that can be taxed, and Ripple is arguing that it's decentralized, so it cannot be regulated in a similar manner. And that whole case depends on the definition of what decentralization is. And in my prior work, the conclusion really was it's really difficult to come up with a single definition because different systems have different interpretation of decentralization. The conclusion was it really is multidimensional. And it also depends on context, what type of blockchain it is, where do you use it. And often, people in marketing throw this term around a lot. You would have blockchain systems designed by one person, used by one person, claiming to be decentralized. And it's kind of tricky. The conclusion from my previous research was really there's no single correct definition. We really have to look at each particular system and try and decipher how centralized or decentralized that system is. We came up with a lot of different layers of centralization. Where can you have centralization in a blockchain system? So you could have network centralization, where you have different nodes that run the network. You can have consensus centralization, economics. This is what Claudia was talking about yesterday with Gini values and things like that. So you could actually have centralization in terms of who owns tokens, who owns currency. There's also centralization at the governance layer. Who controls the blockchain? This last part is somewhat related to what I want to talk about today, the software development. Almost all blockchain systems have some sort of improvement proposal system in place. Bitcoin has Bitcoin improvement proposals. Ethereum has something similar. So the idea is blockchain over time evolves. They all run some code that also evolves over time naturally. And somebody has to write that piece of code, commit it, design a node, and that node is then adopted by other people. And in software development, it's the same thing. We have some form of centralization here, and that's what I wanted to focus on here. One last thing I wanted to highlight before talking about software is it's really difficult to measure or understand what decentralization is. It could mean no one is in control. It could mean everybody has a little bit of control, or it could mean some people control it, but very politely. It could mean any of these things. It becomes really tricky when you talk about developers. So software development is where you take the protocol rules and you try and implement them in some reference implementation. This often manifests itself in some sort of node that you have to run on your machines. This is where also critical fixes are merged. So this is where if you realize there's something flawed with your protocol, you make changes to your node and the network adopts it, and then you can prevent those bugs. Upgrades are also approved in source code. So the system may be very decentralized in its spirit, but what we often notice is that's not actually what happens in practice, especially when it comes to software. So software development matters because almost all blockchain systems, they depend on some piece of code that runs the node. This code is hosted somewhere on a Git repository, not necessarily GitHub, it doesn't matter, but some sort of version control system where others can contribute to the project. Maintainers, there are some maintainers who have rights, who can commit to the repository, some maintainers who can make critical changes, some people who also merge consensus changing code. So what I mean by this is, you all remember Ethereum moved to proof of stake system, and at some point some nodes had to be upgraded in order for the system to move to proof of stake. So somebody had to write physical code that would make these changes. And that's why it's important that we know who writes this code and who has access to making changes in this code. If a tiny group of developers dominate this development, it is a bit tricky because then they can influence protocol rules, they can influence roadmaps, security patches, and things like hard forks. This was a case with Ethereum when Ethereum and Ethereum Classic split in around 2015. And there was a paper in 2019 from people in UCL. They concluded that Ethereum during that time period acted like a dictatorship, not necessarily a decentralized system. Vitalik and a few other people unilaterally decided that they would split and they would roll back a few blocks. And that was a big deal back then because that undermines the promise of decentralization we have. And Ethereum, even at that point, was the second largest cryptocurrency we had. So it really does matter who can make these changes. And open source communities, and there's a lot of research on open source software, how it's designed, how it's maintained. Even in traditionally large open source systems, such as Linux kernel, they're often sort of dictatorships where some developers who have been around forever have more control over what changes gets made. And this is reflected in blockchain software as well. So blockchain software demonstrates a similar pattern in terms of development. There are only a few highly active maintainers. There's only a few people who have been around long enough to understand the code and make changes to that code. But with blockchain, it's tricky because code really defines the consensus mechanism. Consensus leads to money, and yeah, money leads to drama. And this has happened in a lot of blockchain systems over the years. So my main research question here was, how centralized are these open source projects related to cryptocurrencies. And I specifically wanted to focus on GitHub because they have a nice API and I could fetch data from there. So we looked at in total 357 repository. So these mostly include reference node implementation. What we did is we looked at a very large data set from awesome crypto projects. It's a big GitHub repository that contains a lot of different blockchain projects sorted by the number of stars they've received on GitHub. We did some sampling and we ended up with 357 repositories. And what we also did is we wanted to make sure that we don't only look at really, really popular cryptocurrencies such as Bitcoin, but we also look at newer cryptocurrencies, smaller cryptocurrencies, cryptocurrencies that are somewhere in between the spectrum. So we we created these 10 bins with different ranges of stars on GitHub. So that gave us a more representative set. So we looked at everything from tiny tools to large platforms. And this is the GitHub REST API that I used in order to do the analysis. And for each repo, we computed Gini coefficient. This gives us centralization, HHI, I'll come back to this, top K contributors, and something called bus factor. So Gini gives us an idea of concentration, how concentrated the development is. As HHI gives us market-like dominance, and I'll explain this in a bit. Top K share, I looked at top 1, top 5, top 10 developers, how much code did they contribute. Bus factor, I think the easiest way of explaining the bus factor, and this comes from business people, is how many developers do you need to throw under a bus for the project to die, basically. So yeah, business people. Yeah, so the lower the number you have, the more centralization you have there. So what we realized in the end is the median Gini value is 0.82, which is very high. Median HHI is 0.34, which really means 3 developers mostly dominate these projects. So 3 people have more or less control over these projects. Top 1 contributor share is around 35% of the code. So most blockchain systems we use, most of their code, at least 35% of their code is written by one person. And when you look at top 5, it hovers around almost 80%. And in some smaller projects, it's worse. Almost all of the code is exclusively written by a few people. Median bus factor is 4. So if for some reason these 4 developers were to become not available to code anymore, these projects would most likely die. Because these people have written code, it becomes increasingly complicated over time, and it's very difficult to maintain, especially without any documentation. So the conclusion we have is a very small group of developers really drive most of the development of these blockchain systems. This is true across different platforms. What we also did is we didn't just want to look at one timestamp. We looked at Gini over time. We looked at monthly Gini value for these repository because you can see over time commits and data like that. There's very little fluctuation. It doesn't change over time. Consistent inequality throughout different types of projects. There's no natural decentralization happening over time. Because often the theory is when a project is new, only a few people are interested in it. When the project evolves over time, more people become interested, and then they contribute to the project. That's not really the case with blockchain type projects. However, in some other more popular open source projects like Rust and Linux kernel, we do notice more decentralization over time. There's more broad interest, and people tend to contribute more. Especially in crypto, we notice the same maintainers, they remain dominant throughout the years. This is clearly a suggestion that it's not accidental centralization, but rather a consequence of how this ecosystem is arranged. We also looked at different cryptocurrencies. We looked at Ethereum, Bitcoin, Solana. We also looked at quite a lot of domain-specific projects. This is all within the 370, 380 projects we looked at. Decentralization exists everywhere. It's not specific to small, big projects, and it's not specific to one ecosystem. All of them suffer from this. So what we see in marketing is the blockchain is fully decentralized. There's no single point of failure. What we notice in practice is mostly it's 1 or 2 people designing the code that implements the consensus mechanism. So we have really strong mathematical proofs that are published in academic conferences, but the exact implementation of those consensus mechanisms is driven by a handful of people. And what we notice from this is pretty much in line with what we have looked at previously. There's governance centralization, core developers act more or less as dictators. Bus factor issue exists in almost all open source projects, but it's also clearly a case in cryptocurrencies. And with cryptocurrencies, it's more tricky because money is involved. Yeah, so I've already talked a bit about this, that we have dictator-like behavior where we have centralized leadership. The participation by principle is distributed, anybody can contribute, but what we often notice is the contributions are not what makes change to the code at the very end. And not a lot of people are interested in contributing to these projects. So it's a decentralized system with centralized gardeners, more or less. Yeah, this is the first statistically representative cross-ecosystem analysis done on blockchain-related projects. We show systematic and persistent developer centralization over time. One thing I do want to highlight is this form of centralization is not necessarily a bad thing always, especially when it comes to bugs. If there's a security critical bug and you realize there's a security critical bug, you do want a streamlined process in terms of fixing the code, quickly releasing the patch, and the patch then quickly propagating throughout the network. So there has to be some sort of mechanism where you can also push through some centralized control to patch bugs and things like that. It has a huge implication because I think the term centralization or decentralization is thrown around a lot in blockchain domain, both in academia and in industry. And a lot of effort and money is spent on designing these toolkits where we don't actually know if it's decentralized or not. For future work, some of the things that I would want to look into is explore the corporate affiliation of contributors. Because what I noticed, and this is anecdotal, is in most projects, people designing the project are employed by the organizations that back these cryptocurrencies. So it's not, even if the bus factor is 4, it may not really be decentralized in that context. We should also compare these blockchain projects with non-blockchain open source projects. I've done this to a very small scale, but we can do it at a larger scale, and that would give us a better baseline to compare the system with. And also, the decision-making process needs to be well documented. That's not the case for most cryptocurrencies. All of the code and scripts that I wrote for this are on GitHub. You can play around with it. Well, that's it. Thank you.
Thank you so much, Ashish. Questions?
Thanks a lot, Ashish. Very interesting talk early in the morning. So could you please tell us more about your thoughts on whether some of these indicators of concentration or market share, including even the Nakamoto index and so on. So in terms of your analysis of, let's say, a POW or a POS, and also in DAOs in the context of the voting powers, the distribution there, do you expect significant variations?
So this was a few years ago. We published a paper on centralization of wealth, in which we were looking at different cryptocurrencies with different mechanism, proof of work, proof of stake. What we noticed is not really. Almost all of them tend to have similar trends of centralization. There are different factors that lead to this form of centralization. In proof of work, it's really having access to machines that can do well. And those machines are relatively expensive to get, and most manufacturers who have access to these machines only release them out to market once they have made good profit out of it. So it's more difficult there to get access to a larger chunk of, let's say, consensus power. In proof of stake, it's less complicated because you can get it rather quickly. You need more money, and depending on the consensus mechanism, it's easier to get there. But eventually, almost all of them have similar trends in terms of wealth concentration. I would be surprised if it's any different for consensus power either. Yeah. With developers, I think it's the same thing. Okay. Well, Thank you.
Thank you very much. Let's give a round of applause to the speaker. So now is the tea break, and then we will reconvene in 25 minutes at 10:25.
Yeah.
Yeah. Thank you very much.
Before we start the session, I'll make some quick announcements. So Professor Fujihara has given the new updated call for papers for the JPS proceedings, and they are available under this call for papers as a sub-tab. If you click on that, you will get the submission link and also the formal call for paper. Okay. So all the instructions are available there.
Okay, so thank you, Vishwash. Welcome to the second sessions of the day. So it's in circular economy. We have just only one speaker, which is Vishwash. So when you're ready.
Thank you. Yeah. So this is exploratory work with our collaborators from Australia, and this is under review for a project grant. So here I'm going to give you the background of circular economy, how DPP assists in circular economy, and what role blockchain can play in this important topic that the whole world is convinced to go towards, that is sustainability. So circular economy is a class of studies where sustainable practices are invented and applied. So first, let's have a quick understanding of what it is, and then how DPP or digital product passports can help in achieving circular economy, and what role blockchain and other engineering approaches may have in devising such an ecosystem. So these are yet still in guideline stage, these recommendations or these standards. So people are still discussing sector-wise what need to be done and what could be the common understanding across the sector. So healthcare is devising their own thing, civil construction line is devising their own thing. Similarly, electronic waste, city solid waste. So each of such sectors are looking at how they can have best practices in circular economy. So how is it different from our traditional linear economy is a traditional linear economy and recycling economy is, in circular economy, the emphasis is on maximum reuse of a product through repair, refurbishment, and the ultimate objective is to minimize input into the linear chain. So if you want to do that, you need to know that when a certain product is available for reuse, when it is going, why certain product has reached its end of life, is there a potential to reuse, and who is interested in that reuse. So such discovery mechanism is required, so that we all know, but currently sector-wise there are different manual methods that are in force. And that's where we think there could be something that is automated and could be deployed at large scale. And products that are reaching their end life should have a clear description of their component structure and what is the life stage of those subcomponents in a bigger setup, and how they could be, where they could be reused. And then, assuming we have such a mechanism in place, then we should also know where should it go. So what is important is first discovery that there is something that could be reusable or refurbished. Second, knowledge that what is it inside that could be reused. Third, where should it be sent? So that's the circular economy. So to do all these things, what is the mechanism? And that's where DPPs are coming into picture. And DPP stands for Digital Product Passport, which is analogous to what we humans have as passport. And these are the requirements in the DPP. So these are very generic requirements for DPP as a concept, but sector-wise or domain-specific, there are different requirements that those standardization people are developing. So the first one is identification and traceability. Then once we identify the product and its source, and the second one that where we have the history of how this product has been so far used, what is the current state, is there a probable end of life in view, and what one can do if the end of life is coming or has already arrived. Could it be repaired, could it be refurbished, or should it be sent to responsible recycling mechanisms? And then this circular economic concept with DPP will enable facilitation of reuse, remanufacturing, material recovery from those products. And so DPP definitely plays an important role if deployed in the manufacturing process. So the other requirements are about the sector-wise regulators, their compliance, standards across the industry or the sectors, how DPP should be devised, so that they are interoperable. Different manufacturers follow the same standards, so the things could be reused. So the third line is very important. Each DPP, each passport, serves as a digital record that accompanies an individual product throughout its life cycle. So if we assume our mobile phone, which has a CPU, it has a screen, it has a battery, so these components, at least for that particular make as of today, are interoperable, right? If you lose your screen, you get another screen. But if you are thinking of throwing away your phone, and then somebody else is interested just in certain components of your phone, yes, there is a potential, but we don't know whose phone has gone bad, who has that particular model, where we can have that, at what rate, and what is the process. So DPP serves as a digital record that accompanies an individual product throughout its life cycle, containing data such as material composition and origin, manufacturing and distribution history, usage records, carbon footprint, and actors involved across its value chain. Who has produced it, which factory, using what mechanism, and all those things. Okay, so digital product passport is expected to have all these things. So yet these things are still evolving. Sector-wise, people are making efforts how they can have DPP that helps not only the circular economy but also the user aspects. So what are the user aspects? So this is where the challenges lies. Yes, we all know, yes, the data should be available, accessible, we can match it and then use it. But what happens? So these are the two challenges that we are exploring to have solutions for. What should be the technical infrastructure? How should it be? And how that infrastructure should facilitate sharing of data considering its security and privacy aspects of such an ecosystem. So assume in this simple example, there are 3 products, DPP A1, DPP B1, and C1. So A1, B1, C1 are the products, which has subcomponents A1 underscore 1 and similarly, okay? So these 3 products, for the sake of simplicity, assume they are exactly the same products, just 3 items. Then in the first product, first subcomponent has failed. In the second product, the second subcomponent has failed. In the third one, second component has failed. So what do we deduce from just these 3 products? 1, there is a chance that first product, at least one product could be refurbished and reused. So 1/3 of achievement. What else can we deduce? We could say that there is a pattern that the second component is faulty. So there could be a contract manufacturer which is of substandard or something. So it alerts to the ecosystem at a large scale. So this is just a small thing just to understand. DPP wants to represent at a subcomponent most possible way. So sector-wise things are different. For a building, it is different. For mobile phone, it's different. For a vehicle, it's different. So we are playing in the, our proposal is specific to electronic waste, which is a serious problem in India, and also for battery recycling. So coming back to the generic problem of DPP, this is what the expectation of DPP is. There has to be a passport and then also, if possible, description of subcomponents under that product. So assume these are the 2 organizations, the 2 circles, and the first organization is saying, I have a failed product. Do you have a subcomponent? It's asking the another, it's a simple thing. So organizations could be of complex structure. Just to convey the point, what I'm saying is the first organization is exploring the possibility with another organization. Is there a chance that I recover some of my products? Or is there a chance that I can help your organizations to recover certain products? So what do we need for this? We need discovery. We need enumeration of what all digital resources you have, electronic things, and do we have the details of those things, that is DPP. And as you might recollect, that DPP not only keeps description about the product, its subcomponent, but also the state, how long it has been used, what is the current state, and how it could be further reused or recycled, all those things. So if organization 1 says, inquires about a particular type of product, and organization 2 is saying, oh, I have the whole product, so but I'm not using it, take it. So we find such scenarios, right? So this is a simple scenario, very simple, but if you take a scene even at your home, how many products you have, you and your neighbor, you will find a lot of things that you can recover or refurbish. Let's say your apartments, a society or a city or a state or a country. So things becomes quickly becoming very, very data intensive. So what we are getting into, we are getting into a Facebook-like of network of products. So we as human beings, just maintaining our relationships on social media and getting exposed to potential privacy risks. Now what we are going to do here is we are also telling, I have these many things as an organization or as an individual. So what we are representing is not only human relations, but also the ownership of products and their state. And so if it just goes like a graph similar to Facebook, because discovery requires availability for searching what you have. So you cannot be an isolated node and communicate that you have something or you are interested in something. You need to be connected. And once the connections come into picture, you need control. So that's where blockchain, we all know, yes, blockchain helps you in giving this view. Blockchain also helps you to control certain things, but you also know what are the pros and cons of different blockchains and what can we borrow from blockchain and what should be offloaded and what should be on-chain. So we are contemplating all these questions in our proposed solution. So definitely we need discovery in a DPP ecosystem. Means we need a discovery mechanism to discover products that are in use, out of use, their state, and what could be reused at a subcomponent level possible. So we are contemplating, so the two approaches I am showing, these are just broad ways of categorizing the approaches. One is everything you write down in the ledger, when you bought it, what you did with it, and where is it, what is the current state. So the whole trace is on the ledger. But is it a good way? From privacy consideration, no. From search perspective, no. Given billions of devices and their current state, search won't be effective in such approach. So what is the approach that you have? So Facebook has a TAO kind of architecture for its real-time search and query mechanism for billions of nodes and their relationships, and it does it in real time. So that kind of graph architecture is certainly useful in this. So that's where we are contemplating, and we have made some design choices. So this is the one approach we have decided upon. Then comes, how do we control the access to the metadata of products? One would say smart contracts, right? One would say traditional access control lists, but there is something called, again, we have borrowed it from our Facebook work that we did, and there is something called capability lists, which can help in achieving real-time access control policy decision making. So this is another design decision we kind of are convinced that is useful in such a large system. Then privacy of, so if your products and sub-products are open for discovery, if anyone is coming and browsing through what you have, you may not like such a situation. So certainly you will say, why not ZK type of approaches? Certainly we can use that. So there are also methods like tokenization in crypto side, where we can abstract out all the things and we can say, oh, I have this kind of token. We won't give the details what is inside. So those are conditional things that the two parties can agree upon once they make a handshake. Similarly, in such a large system, one of the expectation would be it has to be in real time. So again, this determines what kind of underlying technical architecture one should choose. So it clearly makes a case for blockchain, but not for in its entirety. Okay, so we are borrowing certain things from blockchain, and we are offloading certain logic of the chain, and trying to achieve those design considerations that I showed on the previous slide. So these are the things that we are making use of to propose that DPP ecosystem. So this is where we are going. in a nutshell. So we are converting the linear economy into a circular economy. And if you see, there is this blockchain layer at the core, which is protecting the view from the whole network. Network means network of products, like Facebook of products. And then the chain has the logic, who can read, who can write onto that database. The chain has all the stakeholders connected to it. And so this is just a broad overview to let you understand our proposed approach, that how we are making use of blockchain and other techniques to have a DPP which is handling large volume of data in real time. So the work is motivated by our previous work on Facebook access control policy analysis, and our work on main chain and side chain kind of architecture in Linecoin protocol, and our decoupling work in the privacy space. So we are combining all our previous expertise to propose this new DPP ecosystem. So if you have any suggestions or want to discuss potential alternative engineering approaches, I would be happy to have a word with you. Thank you.
Thank you so much, Vishwas. Is there any questions from the audience?
Thank you very much. This is a very impressive presentation. I have a question about the concept of the passport,
DPP.
DPP.
Uh-huh.
Okay, so could you show us the slide of the network? Yeah, that one. Yeah, anyway, my question is very primitive, but who is the owner of the passport? Is that the company or product or device or materials? And, who is the owner of the?
These things are still unclear, the standards. If it is a firm owning the products, of course the firm should have the mechanism to control all the passports. If it's in personal capacity, you should be the owner of that passport. So the manufacturer is the same. Let's say if this phone is given by my firm, who should have the passport? So these questions are still unresolved. So we know where we are leading to. We certainly definitely leading to a network of networks, similar to Facebook. It's going to be billions of nodes with lot of relationships. It definitely demands real-time query and discovery. So we are convinced that Facebook kind of infrastructure or any social media kind of infrastructure, nodes, edges, policies on the nodes, that kind of thing will work well for this. Then what we are worried of is the privacy implications of these things. And we are also convinced that blockchain plays a role, but it cannot be a completely blockchain-based system.
Okay. Yeah,
So
okay.
we are making all these engineering choices, what to borrow from where and how.
Yeah, thank you very much. My second question is about, you wrote somewhere this phrase, facilitate to reuse. So how do you facilitate to reuse component and materials and products?
The ecosystem allows you to write to the system that I have this product which has this state. If someone is interested, I also write a policy who can read this. And then someone discovers this product and initiates a communication. So this platform is facilitating these two entities to come to a same place. But the platform has to give us a guarantee that privacy is also taken care of. Yeah.
Yeah.
So that's how the DPP ecosystem will facilitate.
Yeah, thank you very much.
Yeah,
Very
thank
nice.
you.
Interesting.
Is there any more?
Maybe it's my first time to raise a question to the speakers, but actually we have already launched the product of DPP in Japan, but that rather targeting for some traditional goods, crafts, type of things, and tying up with European, Italian startups, because DPP will be compulsory from 2026. The question I want to ask is, say, you are targeting the DPP for the circular economy, not for the kind of the normal product production and production and retail. So why you target in a circular economy and DPP? And you've already mentioned about some complication compared to the kind of normal product DPP. But what do you think is the most difficult part to apply DPP for the circular economy?
The difficult part.
Yeah, because normal one is just you check the where the material comes from, where
Correct.
the part
Correct.
manufactured. Correct. But you have to cover the many participants into this scheme as far as you're targeting the circular economy. Yeah. And I think this idea is quite interesting and important. But also it may be quite complicated and a little bit difficult. Yeah. So this is what I'm impressed.
Definitely. The most problematic part will be the trust aspect. Because you are writing, you as an owner of certain product, either individual or as an organization, I have the objective that I want to sell this and get maximum benefit. So I might lie some parameters about this thing. So there has to be a validator or somebody or some system that does not allow me to do this. Or either, again, same thing that we faced in past 20 years over the internet, either use a reputation system or a trust management system or a completely transparent system. So we don't know the answer. So, but definitely this will be a problem. Whether a claim that is made on the passport is true. How do we verify? Yes, we can use blockchain, but at what cost? Do you want to pay more than the actual price of the product? No, right? So we need a variety of mechanisms available in the ecosystem which are facilitating the same design goals. It must be real time, otherwise no use. It must give an accurate discovery, and post-discovery when you are actually making the commitment whether that product is still available. So all these engineering issues are more important in this, I think. Systems are there, but by making one design choice, how it affects other expectations is more important, I guess. So we are going with our experience in some of the past works. We are believing that Facebook kind of approach is good because we understand the access control over those kind of graph networks. We also understand certain applied crypto mechanisms. So we are trying our hands on how do we give such a DPP ecosystem.
Thank you.
Yeah.
Thank you so much. I think that's all we have.
Thank you. Thank you.
So the next session will be the panel.
Yeah, I will join the meeting.
Thank you very much.
Good, fantastic. So you introduce because he doesn't know, right?
Okay, exactly.
We didn't get the bio.
I have it.
So you can
Welcome everybody to the next session today in this last day of the Blockchain Kaigi 2025. And one thing that when we were thinking of the conference, what we wanted to achieve was having a couple of panels about applications. And I think that also Vishwa's presentation was a very good starting point for what we want to discuss today. Because once you can tokenize different elements, many people would first think about financial assets and create more liquid markets for them. However, there are interesting applications that go far beyond this world. And over the years, one thing that we were looking less and less is how is it that we can engage into having a more, as it was said before, sustainable way, but also perhaps we can use use these new technologies and the economics that are derived out of them to better improve the environment in which we live and perhaps to create foster the health of the planet. And this is why the next session is exactly related to that. And there is in Switzerland, I start from the beginning, Switzerland, within the network of embassies and consulates, has always an Office of Science of Technology, and in the most important parts of the world in terms of strategic collaborations for Switzerland, it also has an additional office that is called SwissNext, that networks the different countries. Actually, if we at the University of Zurich started our collaboration with IIT Bombay, and I got to know Professor Shyamasundar, is thanks to the interjection of SwissNext in establishing this link back in the day of the pandemics, and then we continued the collaboration and it landed in this conference today in a way. This is a direct evolution of this. And a person that has been very instrumental for this collaboration, but for many collaborations, India, Switzerland, so if you are here in this country, perhaps it would be a good starting point to try to establish these links, is Lena Robra, who is the head of academic engagement at SwissNext India. Before that, she was also the head of university partnerships. This is the time in which I met her. Lena is very interested in planetary health also because she has a PhD from the National Center of Biological Sciences of Bengaluru when she was working on antimicrobial resistance that is always developed, as we all know. She will be the first speaker today. Then we will have Praful Chandra. Praful is the Dean of Research and Director of the Center of Excellence at the Atria University in Bengaluru. Before that, he got a PhD 9-10 years ago, if I recall right, at the Indian Institute of Science. He has been working a lot on game theory, mechanism design, and social networks. And this is why he developed as well his interest in blockchains and other activities. I'm really happy to have them all. Unfortunately, because of the disruptions that we have had on the flights, as all we know in the last days, they were not able to come here, but I'm really happy that they are still contributing to the conference now. Finally, the last thing that I wanted to say is that this session, I am happy that I will not moderate it because we will have perhaps a better suited person today, who is Professor Sarthak Gaurav, who is a professor at the School of Management here at IIT Bombay. He will be facilitating the discussion later. So that's all that I wanted to say. Thank you very much. Lena, the stage is yours.
Thank you very much, Claudio. Let me begin by saying how sad I am that I can't be with you, because I was really looking forward, and instead I'm now stuck in Delhi, hoping that my flight that I got for tonight for the price of a ticket to Switzerland um, will well, get me at least back to Bangalore, which is my home since the last 13 years. Thank you, Claudia, also for already alluding a little bit to Swissnex. We are a diplomatic anomaly because we are a diplomatic entity that comes under education, research, and innovation instead of foreign affairs. It gives us the convening power of a consulate, but we don't have to follow this strict protocol. We can be a bit more innovative in how we engage with our stakeholders. The image that you see is one of the image submissions to the Swiss National Science Foundation image competition. I really encourage you to look at those images. They're great and one can use them. And I chose this particular one because Swissnex operates like a decentralized network of intelligence, similar to the central nervous system of the octopus. Let me see. Great. Yes. Our mission as a Swissnex in a nutshell is to connect Switzerland and the world in education, research, and innovation, because Switzerland recognizes that India is full of promise. India and also other countries in the world are full of promise and talent, but that at the moment, maybe the two countries don't leverage the full potential yet, and that having the ears on ground in India could help strengthening those relations. We do that with the intent to accelerate positive transformation as one Swissnex community. So for our colleagues in Japan, we also have a Swissnex office in Osaka. So if you ever would like to work with them or take their help to work better with Switzerland, or also Switzerland, India, and Japan together, feel free to reach out to them. This is the entire network, and red is like where we have brick and mortar offices, and the black ones is where we have science and technology officers that can also help you, but have a little bit lesser bandwidth in terms of human resources. I took this little detour because Swissnex is an anomaly, and I would have loved to be yesterday there already for the networking dinner, because I'm a biochemist by background, but I love learning new things, and I would have loved to engage with all of you to hear more about your work, which would have also put me in a better spot to prepare for today's talk, because I'm really a fish out of the water today. In India, we are represented in Mumbai with the Swiss Business Hub and the Consulate General. In New Delhi, we have the Swiss Development Corporation and the Embassy, and in Bangalore is us. We work in coordination, which means we try to support you in whichever best way we can with the specific skills of that team. Now, what do? We engineer serendipity, which means we try and always see who could be interesting or benefit from talking to each other, but might not meet in regular circumstances. And then we try and engineer circumstances where these people might meet. We believe in the concept of weak ties, which means that if you meet someone, you might just have a good chat, but not immediately find something for collaboration. But 2 or 3 years later down the line, you might be like, oh, actually, I need someone with this expertise. And then that conversation you might have had at that moment could be the weak tie that enables you to then make the call and connect with that person. So in that way, we connect the dots. And the last line that I have not added, because it's a recent way of thinking, is we like to burst the bubbles. The bubbles where people work only in their specific areas. We try and burst bubbles and enable people to see beyond their discipline. And that's what I liked us in the previous talk, where the speaker alluded to the fact that like he borrows concepts from engineering as well. How did I come here? Or what is a common weak tie amongst Praful, I, and Claudio? It's a concept called interspecies money, which talks about the fact that at the moment, the way we finance nature conservation is way too less. And it largely operates in the form of charity, where people think whatever money they have to spare and they would like to donate to conservation efforts, they spend on that. But it is not seen as an integral part of our life, and it is not seen as an integral necessity for survival on this planet for future generations. A few years ago, I think almost 10 years ago now, Jonathan Ledgard, who was a professor at EPFL in Switzerland, came up with this concept where he spoke about how, imagine that more than human species had a digital twin with a digital wallet, which is loaded with a currency, and they could charge us for services they provide. Imagine a tree asking you for some money after you sat for an hour in its shade. But similarly, we could infer what are beneficiary actions for more than human species, and can reward, and the more than human species can reward us if we perform any of those actions. This concept works on a decentralized approach, which means there are many places on Earth where people are playing with the concept, and I'm sure Praful will talk about one of those versions later in much more detail and is a lot more equipped to do so. But I just wanted to highlight this as an entry point on where one of the areas of work where we are interested in. And that is often how our work also starts, that like somewhere there's a seed and then we find it interesting and think we could do something with it. And a concept like this really requires a lot of different disciplines. And Praful is also at Atria University, who were the first ones here to come on board and say, like, we think this is also really interesting from a university or educational perspective. I would like to try an experiment. Let's see whether this works. I know before I do that, I wanted to add a little bit more of gravitas to what I was saying by quoting Jane Goodall, who we unfortunately lost a few months ago, because she is much more of an authority than I am to speak or empathize the need for a non-human-centric relationship with planet. She said, surely we do not want to live in a world without the great apes, our closest living relatives in the animal kingdom, a world where we can no longer marvel at the magnificent flight of bald eagles or hear the howl of wolves under the moon. A world not enhanced by the sight of a grizzly bear or her cubs hunting for berries in the wilderness. What would our grandchildren think if these magical images were only to be found on in books? I would like to, this is actually where I wanted to, okay, let me first quickly go this. So thoughts like what we just heard quoted from Jane Goodall prompted us as Swissniks. The last 20 years of Swissniks were focused on science diplomacy, but we feel science diplomacy is now a fairly established field. And so we wanted to focus on what could the next big thing be where we could help use diplomacy. And so we thought we'd try and want to develop a diplomacy for the planet and shift our gaze from a human-centric perspective to a non-human-centric perspective. And therefore we try and engage with like different scientific disciplines and innovations and processes to see like, what if you were to focus on a non-human perspective? And here is where I now want to learn from you or need your input a little bit. Let's see whether this works, this Mentimeter. Because my understanding also from I kind of read the abstracts or from blockchain overall is that often when blockchain is used for sustainability, it is about maybe energy efficiency improvement, or it is about traceability in supply chains in supplying a good for human needs. But very rarely do I find applications where the thought is like first on a non-directly related human process. And so I'm wondering if you could, someone in the audience could give me a sign whether it works with the Mentimeter, whether you can access it with a QR code, that would be great. I somehow can't see you because I'm in a slide sharing mode, but if you could just, Claudia, if you could just tell me whether you can see the
Lena,
slides.
it's working, thanks.
Okay, perfect. So yes, so when I say more than human species, this basically relates to all species other than the human species. And I wanted to hear from you, so it's like a sort of, I wanted to hear your assessment if you look at those three statements. So you should be able to access it on Mentimeter with your phone. And you can then put your input, like whether you strongly agree or strongly disagree on those three statements. Very good. Okay, I have 3 people, I think, out of 13 4 who responded, 5, great. Okay, so we have at least 5 good. I was wondering, Claudia, is it possible that you can go with the mic around and, like, for every statement, if one person would be open or willing to comment on which one, how they rated themselves on one statement, and contextualize that a bit?
Yes, we are here. And
Okay.
we are divided into the two. Yes.
Okay, perfect. So then is there someone in the room who says that I think in the first one where you sort of say my work takes into account the needs of more than human species, it's almost like half-half. I was wondering whether someone who said more on the strongly agree side could give a quick statement on it, and someone who, just if someone on the strongly agree side could give a quick statement or contextualize in what way their work takes into account the needs of more than human species, that would be fantastic.
Yes. So, Lena, my name is Sarthak, and I happen to be the moderator today. So my work is in the context of wildlife health policy in India as well. So that naturally kind of has a gravitation towards working with species beyond humans. And I also work in agriculture risk modeling and developing insurance products that goes beyond the risk factors for humans. So we also work on cattle insurance and working with other kind of species that are considered as so-called pests in the broader ecosystem in agriculture. So I strongly agree with the first statement here. Thanks.
Great. I was hoping for something like that I would learn more things today, more people doing this kind of work. That's absolutely fantastic. Now, someone who said, like, strongly agree on I take a human-centric approach in my work. Could someone contextualize their answer as well? And maybe just to hear different perspectives.
We have yes, please, Pam.
Hi, Lena.
Hi.
You know me, I'm Pam. So,
Pam.
so I'm still a PhD student, so I do not have a lot of work to give reference to, but I really, throughout my PhD or even going through my master thesis, I really looked at the altruistic side of research to help humanity or human-centric approach. I don't know if this is relative, but I have always taken into consideration how to affect people on a positive side with the help of blockchain or technology or computer science through my field.
Okay, great. Thank you. Yes, and the last statement I put in because what I'm hoping to that at the end of Praful's and my intervention, we maybe sowed some seeds for people to see how beyond their current research project, their knowledge could be applied to non-human centric processes. So let's see how that goes. And then I was just out of curiosity, because I think sometimes more than human species is a bit of a mouthful. And this is more of a maybe social science experiment to just, it'll be a word cloud. So just out of curiosity, look, what kind of species come to your mind when I say more than human species? I'll just give you a minute to type in any species that you would think of. Great, thank you so much. You can keep going while I'm talking. Species that have been named more than once appear a little bit bigger. So we have very central the elephant, the wolf as well. What we often observe is like those are really species like the wolf, the elephant, chimpanzees, orang-utans are keystone species. Like we easily relate to the image, and so it's something easy to relate to or remember. And it's important to work with those species as well. Sometimes we want to emphasize that a large part of our soil well-being, of our overall well-being, is also focused or based on insects, on microbes. And that another thing is there are just so many species that are unseen, which is extremely problematic, I think, in the context of the increasing use of AI models who don't see most of the species. They probably see most of the species that have been named here, but they don't see most of the species that go beyond that. I will now switch back to my other presentation. And wanted to just take another minute to introduce the Myers concept, where we highlight, or where we want to say that why are we focusing on this like non-human centric approach? Yes, we have a love for the planet and we have a love for other species, but if we are honest, our life depends on the well-being of these species and depends on an ecosystem, on an intact ecosystem. So it is in our interest to try and preserve and protect and give those species a space to live and thrive. And so in this Myers framework for planetary health, you see that at the end point, their health impact on human health. But this is really the end point. If we want to make sure that the end point is well, the easiest approach is not to try and fix the end point, because if we always try and only fix the end point, we're always running behind. It's like trying to extinguish a fire constantly, like while the fuel is still coming, adding to the bottom. So instead of like trying to extinguish an ongoing fire, we advocate for trying to think of how can we make sure that the underlying fundament is doing well. And this is not necessarily, it requires ecologists, of course, it requires researchers in that space, but it also requires technology. And what we often observe is that like the finance sector, the technology sector, including blockchain, and the ecology sector, biodiversity, they don't very often interact. They start interacting, but not yet enough. And so I'm very glad that Claudio gave me the opportunity to come here today to just speak with you. I'm sure many of you still have like the largest part of their career ahead of you, to try and see whether the exceptional skills that you have in your tool set can be applied to add to the course of trying to like make sure that our underlying support system is doing okay. This is a snapshot of the Interspecies Money project where Claudia was also involved, which is this concept that I quickly spoke about in the beginning, about like having a digital currency for a non-human species. This is a mountain gorilla in Rwanda, and they've actually had a pilot in the national park in Rwanda, where they had like the whole data infrastructure underneath. So there is a KYG technology, a know your gorilla technology. And so each of the gorillas in the national park have a digital twin with a digital wallet. And so then it operates in transactions. Like if a ranger does something positive for the gorillas, for example, remove like a trap that a poacher has put into the national park, then a gorilla in the vicinity will make a microtransaction from their account into the ranger's account. So in that way, interspecies money is not only a tool to give nature agency, but it is also a tool through microtransaction to enhance financial equity, to provide livelihoods to people that live at the fringes with wildlife, human-wildlife conflict, like in India, human-elephant conflict is, for example, a relevant topic. We are also aware that this is not a silver bullet and that it needs multiple perspectives and many discussions, starting from like, should we transactionalize every interaction in our life? So should we transactionalize our interactions with nature? Is English the right language? Can this be multilingual? How do we operate with financial literacy or financial concepts in tribal communities, which might not fit into the typical blueprint of the global north? So there are many questions, but why I love science so much is that I feel science is the discipline that can, the overarching discipline that can have these conversations openly, that can have a scientific discourse from humanities to social sciences to technology to what is possible and what all needs it to build a future that is possible. And so with this, I want to conclude. I want to highlight that as SwissNext, we are connectors. We don't work in isolation. We work with wonderful people like Praful and Claudio, and maybe some of you in the future. Our added value is that we can add or we can implement your out-of-the-box ideas, because we are very well aware that for establishing a scientific collaboration or for organizing a scientific conference, you are the experts. But we can add this out-of-the-box element, like today, I guess it's not the typical talk that I gave, which you would expect at a blockchain conference. So in that way, I really express my gratitude for your openness to welcome me and allow me to give this talk, to make me comfortable by participating in the activities. And I invite you to, whenever you, if any of these spark your thoughts, or if you feel you would like to engage on any of those lines or other ideas, please reach out. On that note, Claudio, Jonathan, and I will host a workshop on the interspecies money concept at the World Biodiversity Forum in Davos. And the whole thought there is, again, that at the World Biodiversity Forum, you meet all the experts who know a lot more species than we do, who know a lot more how these species act, interact, and what they may need. But we can bring in technical expertise like you. We can bring in expertise from the banking or the ecosystem, the banking sector, or insurances or policy. And the goal is to have people like you come to the World Biodiversity Forum, spend this time in the workshop with the experts from the quote unquote other side, so that we hopefully cross-pollinate a little bit and maybe new promising projects come out to ensure that like we have a future on this planet. Thank you. Claudio, I can't hear you at the moment in case you're saying anything.
Nice. Thanks,
you-
Lena. So I'll take it over from
Ah,
So
okay.
yes, my name is Sarthak. So thank you so much for the fascinating perspectives on different paradigms for thinking about planetary health and the potential for blockchain. I will come back to you after Professor Praful's presentation. So over to you, Professor Praful. So can we have the slides, please?
Thank you. So let me start by sharing my screen. And if somebody could confirm from Mumbai that you can see my screen.
Yes, we can, Praful.
All right, thank you. All right, so first of all, I will apologize like Lena here that I was not able to make that in person. I had to cancel my travel yesterday because of the chaos in the air flight schedule that's going on in India. I would really like to meet with several folks there, but as we have it, we are doing this virtually. In any case, Claudio and me met 2 years ago, almost close to exactly 2 years ago in Bangalore, and I met with Lena soon after. And we have been kicking around this idea called Earth Stack, which I wanted to talk about today. It's a project that we have initiated at IIT University. It's in early stages. We are still shaping it. We have talked about it several times, and I think what Lena talked about in terms of going beyond humans, looking at interspecies monies and things like that, was one of the seeding ideas which led to the creation of what I'm going to talk about today. Right. The project is called Earth Stack, but I want to start with how it came about and why we think it is important to talk about today. And this topic today, my talk today, is equally about economics, ecology, and technology. So I'm going to try and cover it from a more comprehensive perspective. And the way I want to start with this is for those of you who have been to the northern part of the country. I know Lena is sitting in Delhi. This is what northern India looks like during the winter months, which starts around October and goes on till February or March, right? Air quality is a huge, huge issue in the northern part of the country that we are sitting in. This is true for almost all of South Asia, not just India. And this, of course, is well known for people who live in India. Very unfortunate. It impacts health of people, but it's an excellent example of how planetary health starts to impact human health and why we should care about planetary health, right? Now, what was interesting to me and what stuck with me during my last visit to Delhi was that this is what the outside looked like. But when I walked into a corporate building, which is one of the glass towers that you can see of the many large companies in India or multinational companies who have offices in India, and you walk into these buildings and you see screens which are displaying things like this. Right now, what is happening in this screen is if you look at the air quality index, which is on the top left under the outdoor panel, you see that the air quality index outside, which is the public space, is 344. The PM 2.5 levels are 181. But indoor, the AQI is much better, right? So we have these enclosed spaces, these private companies with large offices who are running HVAC systems, where the air quality index is much better, the PM 2.5 is much better. Until last year, this was a phenomena which was dominant in large private offices. But this year, there's a huge surge in air purifiers. And this is now becoming the norm in the houses which can afford to buy these air purifiers, right? And the thing that struck me on my last visit to Delhi when I saw this on a TV display inside one of those large MNCs displaying this was the question whether clean air today is a public good, right? Now, it takes a moment to kind of let this sink in, right? And if you kind of look at it from the perspective of economics, right? Economics basically uses this framework of private goods versus public goods, or they also have common resources and club goods. But when you look at private goods and public goods, my last visit to Delhi, as I said, really made me think whether clean air and clean water are really non-excludable. Because if you think about it, people who are able to afford air purifiers are people who are able to work in these large offices where we have HVAC and air purification systems working. They have been able to exclude the masses from getting access to clean air and clean water. And if you think about it, what you have done is you have socialized planetary health, the loss to the planetary health, and you have privatized access to clean air and clean water, right? Now, this is the scene today, right? We think that we have the right to fresh air. It seems almost a given that every human being living on the planet, every species living on the planet, assumes that we have right to breathe fresh air. But we fail to acknowledge that our consumption patterns also mean that we need to give the manufacturing industry the right to pollute, right? And if you don't acknowledge that, if you don't explicitly acknowledge that certain manufacturing setups, the industry needs the right to pollute, that right gets so diluted that almost everybody has the right to pollute. So the absence of property rights around clean air creates a very interesting dynamic where the absence of these rights being tracked, being formalized, leads to overexploitation of the planetary health, right? And this is not something that you see for air only. We see the same thing in natural river systems. Again, in the northern part of the country where we are sitting, the two largest rivers in India, Ganga and Yamuna, have been extremely polluted, right? So we talk about having right to clean water, right to fresh water in river systems. But at the same time, we must acknowledge that we have an industry, we have a chemical industry which the economy needs today, where effluents get created. So there must be a right to pollute. And if you don't create this right to pollute, then you basically have a free riding problem. Of course, the right to pollute has to be monitored, it has to be controlled, and it has to be done in a responsible way. But unless we start talking about these two sides of the coin, we won't really be able to solve the fundamental problems that we are seeing today. Right? Now, there has been some progress made on the legal side, especially if you look at India in 2006, our property rights related to forests, right, are very interesting, right? If you think about forests as a public good, and we tend to think about forests as a public good, but there are tribals who live in these forests. They don't own the forest. They don't own the land they live on. And their ability, they can't cut down the trees. They don't want to, but even legally they can't cut down the trees. But the forest rights in India have given the right to the tribals who have been living in these forests for generations, to some extent, to use the produce which the forests create. So in this case, we have a situation where there is a law, but the law is much more refined, and it does not talk about ownership of forests. Rather, it talks in terms of rights. And I think that's the paradigm shift that we need. We need to recognize that one single public good, whether it's forest, river, or air, has many, many rights associated with it. And economics call these folks property rights, right? So there is a right over sustainable yields coming from a forest, which have been recognized in India for the tribals who live in that forest. Similarly, there is a right over fisheries yield, right? So if you're fishing in a river or a water system, we need to talk about how traditional fishermen fish versus how large industrial corporates do fishing, right? And unless you kind of start talking about that, what is the rights of each of these, you lead to overexploitation of natural water systems. Similarly, if you are setting up a plant near a river system, we must recognize that there have to be rights to withdraw a specific volume of water, whether it's for residential purposes or commercial purposes or industrial purposes. So unless we start talking about these rights, they kind of disappear. Similarly, there is right to access genetic resources. This is becoming increasingly important. One of the things that we work at the university is biotechnology, where we are looking at genetic compositions and DNA compositions of microbes and how to modify them for biotech. But the intellectual property or the right to access the genetic resources in biodiversity hotspots is another very interesting and important right that we often overlook. Rights to prevent carbon being emitted or sequester carbon has received much more attention. And if you think about what carbon credits are, they are related to rights to carbon sequestration and prevention of carbon in the atmosphere. Um, Similarly, what Lena talked about, right of wildlife to access nature, is what I think of when Lena and Claudio say interspecies money. I think about it in terms of rights of wildlife to access forest, right? The point I'm making is that unlike your house sale deed or your car registration, which gives you the rights over private goods like your house and your vehicle, the property rights associated with public goods are extremely hard to document, track, and enforce. Right? And that really, I believe, is the fundamental problem in the economy of today. Now, why am I talking about it in a blockchain conference? Because if you think about what tokens are, right? Tokens, in fact, are the perfect paradigm for representing property rights. Because not only do they capture the information about what is the underlying asset, good, or public good, where is it located, of course, they capture that information. But smart contracts standards, the different ERC standards, can embed the different rules and regulations and property rights associated with that asset as part of the smart contract itself. And for me, that really is the aha moment of where nature tokens, how the public goods economy, how the rights related to fresh water, rights related to fresh air, rights related to forests start becoming very interesting candidates to be represented as property rights. And I think that really is the heart of what we are trying to do in this. I'll briefly talk about how we are thinking about and how we are going about implementing this, and then hopefully we'll open the floor for questions. Right? So what we are talking about is what we call nature tokens. And nature tokens are property rights associated with public goods, right? And the way we want to think about this is, unlike the first and second generation blockchain networks, which allowed tokenization without the participation of local jurisdictions, I think we need a paradigm where nation states and local jurisdictions have the authority and have the unique authority to embed the rights and responsibilities associated with natural ecosystems in digital tokens, right? So the way you want to think about this is, of course, you need blockchain and of course you need the ERC token standards, but you need a layer on top of these public blockchains where the local authorities, the local jurisdictions, whether it's the nation state or the local municipality, can embed the laws of the land and regulations onto these token standards. So think of this like a country or state-specific ERC variants of smart contracts. And this is something that is starting to gain traction in the Indian academic and Indian research ecosystem. As some of you may know, India is a leader in digital public infrastructure, where we have been able to create a digital identity for all humans. We have been able to create a financial payment system where anybody can pay anybody else digitally without relying on a single app. And this has all been made possible because of digital public infrastructure that India has built. And one of the innovations that we are working on as a country in digital public infrastructure is called Finternet. And Finternet is basically exactly this idea that how do you write a socio-legal layer on top of ERC contracts, blockchain contract standards, which allow tokens to be embedded with the laws of the land and the regulations. And it's a unique fit for public goods and nature tokens because a lot of these public goods that we talk about are under the jurisdiction of local authorities and must respect the guidelines and laws of the land. So creating nature tokens is the first part, which we believe is easily doable if we start with ERC variants and modify them to incorporate the law of the land, right? The second part is something that blockchain folks are easily comfortable with, which is transacting nature tokens. Now, from a technical perspective, this is trivial because once you have created a nature token, then of course you can trade it. That's not an issue. The question then becomes one of incentives and economics as to who's buying them. And we believe the way to think about this is that businesses, corporations, industries are the ones who should buy these nature tokens. And these nature tokens the holder of these nature tokens have rights. They have rights associated with public goods, and this right might be to withdraw a specific volume of fresh water, or to the right to pollute up to a certain extent in a particular location, or the right to access genetic intellectual property from a biodiversity hotspot. So that's how you kind of start kick-starting the investment in nature tokens, because they are tied to property rights of public goods, right? And the idea really is to take these proceeds and then invest them to replenish these local ecosystems, because these proceeds go to the local government and the local populations who are responsible for managing these nature ecosystem. Now, I want to say that if you think about it from this lens, then the biodiversity credits in the European Union, the green credits in India, and the carbon credits worldwide are all variants of nature tokens who capture certain rights and responsibilities associated with public goods. But we can create many more such innovations, and interspecies money that Lena talked about is an example of how do you create a different kind of a property right related to nature and public goods, right? The last part of the equation is ensuring trust, verification, and access to these nature tokens. And we believe the way to do this is to kind of look at other technologies. The three technologies that we are looking at is satellite imaging, which is becoming increasingly powerful, environmental DNA, which you can get from soil and water samples from different localities, and artificial intelligence to measure, validate, and certify the impact of these nature tokens after they have been created and transacted. And this impact can be captured in digital certificates, which again become an interesting paradigm to be issued to businesses. So once you issue these businesses and corporates verifiable credentials, they can use it to prove that they are carbon neutral, net zero, nature positive. And of course, they can be protected with cryptographic proofs like ZKIP that come with blockchain, right? I'll stop here. I'll summarize what I wanted to kind of say, hopefully the last slide here. I think the fundamental issue that we have recognized is that the state of the planet is where it is today because we have not correctly assigned value to rivers, forests, clean airs, and non-human life forms. And this value of public goods is multidimensional. And the way to think about this is in terms of the different property rights that can be associated with these public goods. Tokens in blockchain are the perfect mechanism to represent these rights. Carbon credits, biodiversity credits, interspecies monies are all manifestations of nature tokens. And satellite imaging, eDNA, and AI can verify the authenticity of these tokens. I'll stop here. If you're interested in working on this, we are looking for a PhD or a postdoc position, and we are happy to talk to you if you're interested. And if you're a researcher or a professor, happy to collaborate with you. I'll stop here and hand it over back to the organizers.
Thank you so much, Praful, for that succinct and very kind of well-framed set of arguments about, in fact, I'm happy that you could extend on to what Lena presented about interspecies money. And thanks for highlighting the importance of thinking about rights in the public goods context, more so when we're talking about airlines monopolizing certain aspects of public goods, whether questions regulation and centralization have been debated for such a long time. Now, before we open the floor for questions, I would take the liberty to raise a few questions to both our eminent speakers today, starting with Lena, then over to you, Praful, because when we start looking at the applications and potential use cases that both of you have summarized today, one question that comes to mind is, how do you have the buy-in among the stakeholders? Particularly, there's an important aspect of regulation and governance that is built into these technologies. But from your experience, to start with you, Lena, could you please tell us a little bit about your thoughts on how can we go about having that traction within the stakeholders, given the kind of variations and awareness about blockchain technologies and its applications to begin with, and the kind of broader applications we've seen in the fintech space in particular, that is clouding the policymakers' understanding of blockchains as largely cryptocurrency kind of instrument platforms. So in that context, Lena, any thoughts on how the interspecies money, from your experience, you could tell us more about how stakeholder engagement could be strengthened, and if any insights from SwissNexus work.
Great. Thank you so much for the question. And I actually like to start with different examples than interspecies money, and Praful's talk prompted me to it. There was already also a pilot by a different group on tokenizing like protective actions, and that was on protecting blue whales off the coast of California. And so basically the thing was that a blue whale has a certain value because it's a carbon sink in a way. So if the blue whale passes away, then so much CO2 is re-emitted, and also like the kind of CO2 sequestration that a living blue whale does. And the problem was that blue whales were increasingly hit by ships and were therefore dying due to that. And so they established an early warning system where a captain of a large ship would get a warning saying there are blue whales ahead, can you please take a detour? If the captain would take that detour, they would directly transfer $5,000 into that captain's account, and that transaction was tokenized. And so then companies could buy these tokens to meet their ESG targets. And so here you had the incentive, because Praful spoke about incentives. Here you had a direct financial incentive for the captain of the ship to do that, because there was direct immediate cash transfer. And you could then like fill that financial gap that you created by making that transaction by selling it to companies who need to show that they do something for the protection of nature. And because of the tokenization, it was linked to a very clear direct action. I think sometimes with carbon coins, it is too abstract for people to see like how does it actually impact climate change, what is the actual positive action that I've taken, and there are all these discussions whether these tree planting projects actually do what they're expected to do and so on. But here was an example where you could really say on this day at this time and these coordinates X happened, and that is what you did. So that might be an incentive. In terms of how do we get the buy-in, that's a very difficult question, because I think in the end it ties to two things. One is behavior change, which is just, I think, one of the most difficult things to achieve, especially if there's no direct benefit. Like if I give you a discount on buying a jacket, then you have a direct benefit, and yes, you will choose to buy the jacket I want to sell you versus the jacket of my competitor. But if I were to tell you to invest into an interspecies money concept, it's very hard for you to sort of link that to a direct benefit for you. And so I think people still, those who have people still haven't realized to what extent our quality of life depends on an intact ecosystem. I think too many people still think that it's optional. Of course, I'm generalizing here a lot. There's a large amount of the population who does not have the means to think about it, but I would also argue that those are the ones who pollute the least and use the least. But overall, amongst the population that can make a choice, I think the awareness that this is not a question of charity or being nice to a cute panda or to an elephant, but it is actually our lifeline, needs to settle in. Now, how can we achieve that? As Swissnex, how we try to achieve that is really leveraging our power. So, for example, our ambassador might meet like Ananda Nilekani, or might meet someone at the World Bank. And if we manage to reach those people who can move the needle or influence people, that is how hopefully the message trickles through. And that's with that motivation we also applied to the World Biodiversity Forum with the intent of bringing really, Switzerland has a very heavy banking sector, to bring heavy waiters from that sector there and find a way. So we try and enable those two sectors to talk with each other, not in this you are good, you are bad way, but in a way in the end, we are all living on the same planet, and it is in our interest, or it should be in our interest, to enable life on this planet for future generations as well. So we try and enable a neutral, trusted space where people can talk not with the hat of the company that they're wearing, but can we really see your inside? Can we really trying to touch the emotional side of people, because that is often the turning point for behavior change.
Absolutely. Thanks a lot, Lena. Praful, agree or disagree, or you'd like to add on to what Lena has mentioned?
No, I think
particularly the scalability.
there are three things I wanted to say. The first one, I think Lena covered very well. I think make it real, right? A lot of the time when we are talking to stakeholders coming from a technology background, we get lost in the technology aspect. But most stakeholders want to understand what is the impact on the ground, right? So I think the example that she gave of Blue Whale is an excellent example. The second thing is make it personal, right? Basically, when you're talking to a stakeholder, think about the language that they speak and try to articulate why this is important to them. Now, the third point, Sathik, that you mentioned is important, right? For better or for worse, the Indian ecosystem or Indian ecosystem tends to, at least the regulatory ecosystem, tends to relate public blockchains to cryptocurrencies. And one of the things that we have found is not to use that word and just talk about the application rather than terms like blockchain, because that tends to turn people off for a variety of reasons. Some of them are fair, some of them are unfair. But as I said, don't have a technology discussion with the stakeholders who want you to adopt. Have an impact discussion and have a discussion on how it's important to them and their priorities.
Thanks, Praful. Now, in the interest of time, let's open the floor to some questions. Now, if there are any questions to both our speakers, you could please raise your hand so that we can get the mic up there. Any thoughts, any questions, any suggestions? Okay, so Praful and Lena, seems there are not too many questions, but I would take that again, freedom to pose a question on scalability.
Sarthak,
But in the meantime, Professor
question.
Shyamasundar online has a question. Over to you, Professor.
You know, Praful and Lena, I have one question. I think what you have touched like Delhi, you know where the problems are. It is not a question of trying to tokenize. It's a question what we know and we don't want to solve. Now, in that context, why you go for blockchain technology? It is just the database and the environmental factors. Everyone knows for the past 5 years, it is the burning of the husk that has led to problems. And also perhaps Swiggy and others have added fuel, the smoke to all these things. We know the factors are. But I think the important factor you have to make a difference between Switzerland and India is, in Switzerland, if you go to a village, they would like to live like what they have been. Whereas in India, even if you go to a remote village, they want to live like where the most urban city lives like. So in that sense, somehow, I'm not sure whether blockchain technology is the right technology for these aspects. Any comment?
You want me to take that, Lena?
I would actually like to throw this comment into the audience because I'm not a blockchain expert, but I feel there's always merit in trying to explore if and how a technology could be used to deal at least with certain aspects or whether it has potential. And so for me, like I would learn from the audience whether with their and you included, Praful, because you're very familiar with blockchain technology. If you see now coming from these conversations, if you can imagine certain use cases for blockchain in small aspects or in bigger aspects, and sometimes the answer is no, that is also fine, but I think we should always ask and explore. Yeah.
Yeah, Praful, over.
I think, again, we are getting too focused on the technology, right? Ignore blockchain, Professor Shyamasundar. I would say just throw away blockchain. The thrust of my talk was property rights associated with public goods, right? How we enforce them is an implementation detail. But I would like the discussion to be around, should property rights around public goods be documented, be captured, and be tradable? I think that's really the conversation that I would be interested in.
No, I have a question on this. Long back, couple of decades back, LA, Los Angeles was a smoky chamber. And then when the Olympics was held in Beijing, fortunately or unfortunately, I was there during that couple of months before or after. It was almost horrible to live like that. They have overcome. The question is that it's not the blockchain, It is our understanding and a resolve to solve that. And so for that, don't fix the technology first. Try to see what is the way this can be overcome, and if you want to have a test pilot, you can go ahead. That's my impression is, because blockchain is not a solution for everything.
Sir, I'm again saying, please ignore blockchain.
Okay.
My conversation.
I have ignored. If you ignore blockchain, I have no issue at all.
Okay. My issue, the thrust of my discussion is property rights of public goods.
Yeah, just to clarify, so thanks, Mr. Shyamasundar, for raising that important point that we shouldn't just be fixated in blockchain as a panacea for much of the problems, but here Praful has rightly highlighted the importance of thinking about rights in the public goods context, and that may raise a lot of questions about how blockchain applications could be developed. Lena, you have a response to it or any thoughts? Yeah, Lena, please go ahead.
Yes, yeah. I would say please don't ignore blockchain. But from the perspective, of course, I'm not saying technology can fix everything, but I think issues are complex. Also, the air pollution you alluded to in Delhi. So depending on who you talk to, I mean, you hear people talking.
Yeah, Lena, sorry, I think your network got disrupted.
It's a very complex thing. And I'm not saying that blockchain can fix it all, but I think we need to talk interdisciplinary to figure out where can blockchain add value, or where can, like, if a blockchain expert talks to someone in the municipality in Delhi about air pollution, or talks to a satellite imaging expert, or talks to an ecologist, just sometimes a conversation can open doors on, like, this is where the technology could help. Because if I don't understand the technology, like, I mean, I have a surface level understanding of blockchain, I don't know where it could be utilized. And similarly, someone who might be focusing on blockchain very deeply might not be able to see the entire spectrum where there's an actual use case beyond the case they're working on. And so in that way, I really advocate for having these conversations without the expectations that they will solve the problem, because it is a complex problem. Something like air pollution, a lot, again, goes back to human behavior as well. But please do be curious. That's actually the thing. Be curious about, like, other people's profession and expertise. And we never know how this might then pan out to become a good solution for a maybe small problem, but many solutions to many small problems might make a compound big solution to this problem.
Well taken. So thanks, Lena. In fact, for the interest of audience, those of you interested to understand what is the state of the art in terms of blockchain applications in the space of sustainability, even an extension of the work that Vishwas presented in supply chain context, as well as planetary health and all, there are a lot of recent systematic reviews that have been published. And if those of you are interested, I'll be happy to share some of these, including with our eminent speakers today. So with that note, we have two more questions. Claudio?
Yeah, thank you very much. I only wanted to comment also on Professor Shyamasundara's comment that I agree that it is not necessarily true that blockchain for blockchain's sake will solve a problem. And I also understand that there are some applications in which blockchains was overused, and specifically when we are thinking of creation of tokens to represent things. And I think that, for example, Ikei's presentation yesterday was mentioning actually that as good as the idea of carbon credits or can be in by using blockchains, in many cases the data that has been input actually bears no factual value, even not financial, but factual. Okay, and here I think that without the intent to overuse it, I think that Praful was mentioning one important aspect, which is, do we want to make some of these elements, these rights, tradable? And I think that because of the layer of applications that we can build on top and automatism that we have thanks to blockchains, not only in terms of common goods, but I would say looking forward into the vision of the interspecies money and trying to give agency to some of agents that are completely underrepresented in the in society and also in economy, even irrespective of the value that they have, intrinsically, not monetary, is an interesting idea to explore and to see how it can be moved forward. It is a very challenging problem, mainly because we know how blockchain became associated with a set of highly speculative assets. So the question is whether, I think that the main challenge of the idea, something that we discussed with Jonathan, with Lena several times, is ensuring that if we are able to realize some of this vision, okay, how to ensure that this happens not as a ultimate speculative element, but as something that is really bringing value. I think that there are a lot of questions to be addressed yet, but it's let's say an interesting idea to explore, exactly because of the fact that the technology facilitates for the first time a range of composable elements that may be interesting in this space. That's what I wanted to say.
Thanks, Claudio. So thank you to both our eminent speakers in today's panel who have given us a very important glimpse into understanding and appreciating the complexity of blockchain applications, even conceptualization in the context of planetary health, sustainability. Lena, particularly when she opened up with that engaging Mentimeter, and also thanks for keeping that hybrid format engaging, Lena. So that also threw up a lot of questions about awareness and diversity and the importance of acknowledging the complexity that Claudio also referred to. And in the regulatory context, thanks to Praful, and the importance of rights and the kind of rights to public goods and the multidisciplinarity that is necessary for such projects to even be conceptualized, developed, and adopted, implemented, and eventually scalability is going to be an aspect that all of us here in this conference have been thinking deeply about. And I'm very happy to note that both of our speakers have also extended an invitation to the participants to have further conversations going forward. So thank you to Claudio for facilitating the session. And thank you again to both our speakers. You might be missing out on the tea or coffee here, but look forward to catching over tea or coffee in the near future. Thanks to our online participants as well. So we'll take a short break with Vishwasa's permission. Thank you all. Have a great day. Bye.
Thank you. Bye-bye.
Bye.
Bye.
Unfortunately, no break. We will go soon. So we'll start with the next session on smart contract. Just have one speaker, Shepan Gurgul from University of Zurich, who's going to be presenting on design and evaluation of AI agents for MEV extraction on rollups.
So, can we start? Yeah, okay. Hello everyone. So my name is Stepan, and today I have a presentation for you about AI agents for MEV extraction of rollups. What you can expect from this presentation is I will show how we built MEV bot, then how we also created AI agents within the ELISA-OS framework, and then how we ran the simulations and aggregated the results, and then we got the charts from it. So yeah, let's start. This is our agenda. We'll go through the motivation now. So basically there is a big research gap that most MEV research is concentrated about the layer one. However, there is not much research going on about the MEV on the rollups. However, we can also see the clear migration of the activity to the rollups. As you can see on the chart here, is a chart of three aggregated rollups, Arbitrum, Bayes, and Optimism, and daily they can have as much as all of them combined, they have around 50 billion US dollars of daily volume on their dexes. And from this, we go to the problem statement. So we want to understand how private mempools, fast finality, and also sequencer-controlled ordering will reshape the MEV on the L2. And then we also want to evaluate whether the AI agents can actually earn the competitive edge for the MEV bots, and so we can earn more of the profit. Research questions. So first one, what are the profitability and risk characteristics of the certain L2 MEV techniques? Second one, so actually how profitable can be cross-dex arbitrage on the L2 rollups, once we also account for the AMM fees, price impact, and the gas. And the third one is what are the most effective way to use AI agent in the MEV extraction. Regarding the background, so here's a quick note about the rollup. So rollup is layer 2 scaling solution that executes transaction off-chain and then sends them compressed back to the layer 1 network. Each rollup is also composed of the sequencer. Sequencer is basically just a component node that's responsible for ordering and batching the transactions. That's how it works. You can imagine sequencer takes, for example, hundreds of transactions, it encapsulates them, then orders and then sends batch down below to the layer 1 blockchain, which is often Ethereum. Also, each of the sequencer can be built in different way. So they have some different ordering policies, how they order the transactions. For example, Arbitrum has first come, first serve sequencer, and Optimism and Bayes, they have priority fee ordering of the transactions. And as I just mentioned, the transaction ordering, so on the layer 1, the validators and the block builders, they compete to include the transactions and order them. However, as I just said before, on L2 there is a single sequencer responsible for doing all of it. And therefore it changes the MEV on L2, how we have to approach it. One of the main differences is the mempool design. So on the Ethereum network, for example, the mempool is open, so the MEV bots can just go to the mempool, scan it, and then search for the transactions they want, for example, to sandwich. However, on L2 there is no public mempool, so the view is only restricted to the sequencer. Also about the latency, so rollups have the fast finality around 2 seconds for some of them. Arbitrum has around 250 milliseconds. However, on Ethereum is much larger. So there is a need for the faster and ultra low latency MEV bots on the L2. And we mentioned transaction ordering before. Now regarding our methodology, so this is actually how we build this stuff. So first we have determined the deterministic economics. So in all of the analyzed pools, we will use wrapped Ethereum to use this USDC pair. So always when I will say X, it will mean the wrapped ETH, and Y is USDC. And we define the profit function, which is pool-to-pool payoff function, and all of the MEV opportunities they have to go through it. The function is basically just how much in USDC terms we receive on the sell leg of the trade, and we subtract from it how much we paid on the buy leg. And because this is a function, we can very easily estimate the maximum or minimum of it. In this case, we take the maximum because the maximum will be the best chosen trade size that will give the MEV bot the most profit. And from it, we turn this into two optimal quantities, MAV and EV. MAV stands for maximum arbitrage value, and then EV is just expected value. MAV is, as I said before, the best profit attainable at the size of the trade, and EV is just MAV adjusted for the execution cost and risks. So we will also subtract the gas costs, and we also introduce estimated probability variable that we have to set up. And these two will be used quite often, so what basically EV goes to is just the expected profit for the MEV bot at the end for after all of the costs. Then on top of it, because it's a L2 rollup, there's also some randomness. So the L2 rollups add the randomness through the synchronized sequencer with the ordering rules. There is also latency jitter, and because the mempool is closed, we cannot see the transactions. The sandwich attacks have uncertain victim arrival times, and also the size of the victim trade is unknown, so we have to model this as well. Therefore, we simulate the first come, first serve sequencer order for each copy of the transaction. We also have to simulate the tip-based priority rules. So the more we pay for the gas, the more likely the transaction will move higher in the batch. And then we also have to simulate the arrival times of the transactions and the victim sizes, as I said before, because mempool is closed. So the sequencer we model as the priority queue. And instead of reproducing the whole mempool, we will just measure what matters the most in the MEV terms. So it's network latency. And this is basically, it basically goes down to the propagation over RPC, batching, and transaction queuing delay. And we calibrate it from the data we gather from the rollups. And this also gives us the baseline arrival time for the transaction. And the T-based priority, we just model it as the time shift on top of the previously mentioned network latency. And also for the sandwich attacks, we have to look at two things, and we have to know them. So does the victim trade appear in the window? So each swap we model as the poison process. And also we need to know if it does appear, does it land between the front running and the back running leg of the transaction. And if it does appear, we assume, therefore, the sandwich attack is successful because we have first come, first serve sequencer. So we also have to model the victim trade size, and this is basically we just take data from a rollup and we look at the historical swaps, and then we save it into the function, and this is that's gonna be basically where we take the size of the trade from historically, and then the victim arrival window will be basically the time between the front running and the back running leg of the sandwich attack. And then on top all of it, we run the simulations. So we will do Monte Carlo simulation. Definition of Monte Carlo is a computational technique that uses repeated random sampling to predict outcomes of the uncertain events. And in our case, it involves building a model. So this is the system that we built, and we run it many times with the randomized inputs. So as I beforehand mentioned, network latencies, gas tips, also victim arrivals, as well as the size of the victim trace. And then we will analyze the range of the results to understand the risks and profitability of the L2 MEV. And in each of the Monte Carlo trials, we'll draw the latencies, then we will run the sequencer on top of it and compute the profitability and risks. And then we will repeat it thousands of times, I think it's 4,000, to estimate the averages and the profitability of MAV, EV, and then also the risks for the sequencer. Three approaches MEV we are actually doing. So first we are doing cross-dex arbitrage. So we will just simply observe the spread between two liquidity pools on the same rollup, and then we will check MAV and the EV to assess the profitability. So this is basically just cross-dex arbitrage on the same rollup. Then we will do the sequencer spamming, which actually targets the same economic opportunity as the cross-dex arbitrage. However, because the transactions are very cheap on the layer 2s, we will just try to capture the arbitrage by these spamming the transactions. And lastly, we will try to perform standard sandwich attacks on the single liquidity pool. And sequencer spamming and sandwich attacks, they both use the transaction policy. This is just the place where we specify how many transaction copies we will send, also the tips, gas tips for the front running and back running transaction legs, as well as the back delay. And if we set it up greater than 0, this will create this window for the sandwich attacks. And now we can actually look into the system components, so what we've built. This is the whole architecture of the system. We'll start from the left, environment and data. So we take the RPC blockchain nodes either from Infura or Alchemy, and we focus on the layer 2 rollups. System can handle any EVM compatible layer. However, in this work, we focus mainly on the optimistic rollups, so it's gonna be Optimism, Arbitrum, and Base. And then we've built the research MEV bot composed of the 3 layers. And basically from the detection layer of the bot, we will connect to the exposed RPC nodes through the WebSocket connections, and we will subscribe to the liquidity pool events. And we can handle two types of the AMM. So it's gonna be CPMM and CLMM, so the constant product market maker and the concentrated liquidity market maker. And depending on the type of the pool, we will subscribe to the different subscriptions. There is also the registry, so we have to hard code which DEXs we use and also which tokens we use. We have also health codes and the latency filters, so we will check if the RPC connections are stale, if we are working on the old data or it's new one. We also pull the gas chain periodically with the HTTP connections. And then we will record all of it and we normalize it into one ND-JSON file. So ND-JSON is basically a file that each line is a separate JSON object, and each line in this project will basically correspond to the single MEV opportunity. Once we normalize it, we pass it down to the decision-making layer, and this is where the three beforehand mentioned strategies live. This is where we have the deterministic economics layer, which I explained before. Then we pass it to the stochastic layer, and before we also check the MEV guard, so if the budget for trades is all right, if the trades are fresh. There is also control plane, so this is where we specify the policy.json file. Policy.json file is basically an environment file, works as .env, and this is the file that the MEV bot will always periodically read, and this is file where we also specify basically most of the important stuff for the MEV bot, like transactions, gas tips, guard delays for the transactions and everything. And lastly, we have the monitoring of the system. This is where the AI agent layer is. So we have swarm of 2 AI agents built within the ELIZA framework. There is also a custom plugin that will connect to the policy.json. And we have the monitoring system. So we have the Telegram notifications. We have Discord integration for two-way chat with the AI agents. And there is also observability website where I just we can stop the bot, we can stop the bot, run it. We can also look at the latest errors or if anything is going wrong with the bot. Now moving to the AI agents. So we build it within the ELIZA OS framework, and we have 2 agents. One is ELIZA, and basically ELIZA will just act as the system orchestrator for a whole MEV bot, and it will connect to the API with the custom plugin that we've built, and the custom plugin will read or modify the scopes of the MEV bot. And there is also Dexter. He will act as the personal MEV market helper, so we can just ask him for the directions on which liquidity pools we should tackle next. It can also monitor trends or help to discover new pools that we can subtract value from. Also, each of the agents has the character file within the framework, and character file you can see here in the JSON is basically a file where we give the name, plugins to the bots, APIs, AI models, avatars, where we also have to specify the behavior rules. So we will give the AI agent how he has to react. We will give him topics, examples, questions we will ask, and then also response styles he should respond in. And these are the screenshots from the ELIZA OS. So on the top, you can see how it looks. We can switch on and off agents. We can also add them to one group, and then we can talk both of them. Therefore, we can orchestrate them better. Down below, you can see the this is chat with ELIZA OS agent. And basically, we will just ask, we will try to get what's the value for the EV, and down below we'll tell it to update some of the scope. So we will, for example, set the number of backrunning transactions for the sandwich attacks to 1. And on the left-hand side, you can see the talk on the Discord server. So it's dual channel. And this is the zoomed-in architecture of it. So everything is Dockerized. Each agent has a saved state in the Postgres database. Also, each of them uses OpenAI. Dexter has integration with Defilama, CoinMarketCap, as well as Discord and Zapper. And ELIZA uses the custom plugin. And this custom plugin will talk to the control plane on the MEV bot through the HTTP calls. and it will read or write the policy JSON, and then the policy JSON file, as I said before, is basically just loaded. It loads the parameters to the MEV bot, and there we have the feedback loop, so we can actually check if the proposed changes and what we changed help the value. And now the results. Data collection, so we collect data from 3 different optimistic rollups. It's base, Arbitrum, and Optimism on 3 different dexes. So we have Uniswap, PineSwap, and SushiSwap. We monitor their 6 different liquidity pools, and we cover around 124,000 blocks on Arbitrum and about 16K blocks on both base and Optimism. And here's the table. I just want to point that on each rollup, the liquidity pool's depth is different. So the base has the deepest liquidity pools, then there goes the Arbitrum and Optimism. And the same way we will just lay it down on the chart. So the most left one will be always base, the deepest one, and then most rightward will be the most shallow pools. And just the reminder how data collection works. So we connect to the blockchain nodes via WebSocket connections. We track the LP events and then the pool updates. We will reconstruct prices and detect MEV opportunities. So this is where the deterministic economics and the stochastic layers goes in. We compute profits and risk with models. So we run the Monte Carlo simulation, and then we'll aggregate the results and build the charts. So the first research question is, what are the profitability and risk characteristics of the L2 MEV techniques? So first, here we have the sequencer spamming. On top is the EV in USD per trade profit, and down below you have BPS in basis points, just the percentage change per percentage gain per each dollar traded. So with the sequencer spamming, most of the runs are nearly break even. The median is marked with the small diamond. And there is also very right small tail, so it can be profitable, but it's not this profitable. However, there is also a risk of being flagged by the sequencer as malicious actor, because we will spam the sequencer, and it can further collapse the expected profitability of the MEV bot, and the combination of deep LP and the modernized size would work the best for the extractor in our case. Now about the sandwich attacks. So in our simulation, it's mostly profitable on the rollups. It has some positive EV, but however, sandwich attacks, they will look more like an occasional opportunity rather than the scalable business, because still the meme pool is closed and we cannot detect the motion there. And however, for both of the sequencer spamming and the sandwich attacks, both of the results should be taken as the upper bound. Because we also omit another MEV bots competition, and we also omit the MEV sequencer mitigations, how it can basically flag our transactions that they're bad. And now the second one, so how profitable can be cross-dex arbitrage on L2? Cross-dex arb on L2, and it's again the same. Top chart is the USD profitability, and below is in the basis points. So it can be as profitable as 40 USD on the deep rows on the base rollup. So the deeper pools will let us trade the larger input sizes in wrapped Ethereum. Therefore, we can earn the most dollars. However, if we look at the chart below, across all chains, the MEV opportunities will look exactly similar. So the profit differences mainly come from the trade sizing, not from the better per dollar edge. And also want to mention that for the cross-dex arbitrage, we can do it in atomic way, because we are on the same rollup, so we can also fund the position with the flash loans, so therefore it can be not capital intensive, which is helpful. Now the liquidity impact against the trade size. So as expected, price liquidity impact is non-linear, and small trades have almost no impact. However, for the bigger trades, the impact explodes. You can see it on the x-axis. For the small charts, impact is almost zero, and when we increase the trade size, it will explode basically. And small trades are mostly gas dominated, and large trades are the slippage dominated. And you can see on the lower chart, Arbitrum case, the chart is U-shaped. It basically, in the first part, this is where the gas dominates, and there is break point where the impact starts to dominate. And this is helpful for the cost optimization of MEV bots, so we can check what's the best input size for the trade. Now very quickly about the gas share. So as expected, gas costs dominate at the smallest MEV trades, and then as we increase the input, as again the input becomes bigger, the further gas cost optimization basically is almost pointless. So we have to optimize for the deeper liquidity pools, better routing between the liquidity pools and the other stuff. Now the third one, so what are the most effective ways to use AI agent? So we discovered that in actually L2 realms, most of AI agents are more suited for the system orchestrators rather than trading, and they are the most effective to use for live tuning of the MEV parameters. And here on the charts you can see that most parameter changes have EV gain around 0. So most changes that the agents did basically had no impact or very small impact. And however, some more meaningful profit changes would require richer state or more research. And the same goes for the sandwich attacks. However, if we measure the parameter rotations by AI agents on 1 minute, 2 minutes, or 5 minutes scale, we can detect that the parameter changes, they react the fastest to the market changes. However, the 5-minute rotations, they will deliver the largest cumulative updrip for the MEV bot. And the conclusions, L2 MEV profitability is real, but it's very tight, and sequencer also has full control over ordering of the transactions, so it can filter out spam or malicious transactions, further reducing the MEV profitability. And AI agents fit the most for the control plane, so they are the most effective as the parameter tuners and for the MEV bot orchestration. Thank you.
Thank you, Shepan, for the presentation.
Thank you.
Questions? Then we wrap up. Thank you so much.
You.
So we will continue with the last panel of Blockchain Kaigi, and it will be moderated by Professor Tesone.
Thank you very much, ma'am. Well, we wanted to have a final panel, thank you, and that is going to be centered around different elements that allow us to, that we have been in the air all the time during the conference. That is CBDCs, actually. But specifically because CBDCs are a very interesting use case, and they have been perhaps also more in conflict or also coexisting, let me say, with the stablecoins, is the word that I was searching for. Perhaps we're going to extend a little bit to digital assets in general. It's not for me good, so I can keep talking. And therefore, we're going to have this panel now. And it's a pleasure for me to welcome one of our speakers yesterday, Ikei Matsuda. We know him, he's a Japanese entrepreneur. He's part of Digital Platformer. And the other person is Sarthak Gaurav, who is a professor at the Mehta School of Management at IIT Bombay, who kindly accepted to join. So here we are setting up the stage. Bear a little bit of patience with me.
Can I use a brief introduction about what we are doing in
Yes, please, go ahead. And Ikei-san will be, Ikei-san will be, Ikei-san, sorry. Ikei will be giving a very short presentation about his activities in this space. Yes, we can see it. Thank you very much for joining.
No, it is fine. We like it. Hi, hello everyone. Just I come back here. Yeah, we enjoyed a lot last night, but now today is the last day for this blockchain Kaigi. And thank you very much for Ikeda Sensei and others to invite us to come here. I really enjoy this blockchain Kaigi, and also it's quite fruitful for me. And as I just explained who I am, I'm a CEO of Digital Platformer. And Digital Platformer is, as I told you, providing a DIDVC technology. And it's not so common that the DIDVC is used to the real-world activities. But now in Japan, we are providing this DIDVC platform for the kind of data, personal data system for the regional government, as well as to open up the banking account. We are using this DIDVC. So this is what we are doing. And also, as I told you yesterday, we are providing our platform of tokenized deposit to Hokkok Bank. It's a middle-sized regional bank, but this is the first real use case, not a POC, real use case of tokenized deposit in Japan. So the reason just I set up these companies, as I told you, I was co-founder, I am co-founder of Soramitsu. Soramitsu was established almost 10 years ago, February 2016. I met Makoto Takemiya. He's now Japanese, but actually he's Japanized. He got a Japanese nationality from, and he just abandoned U.S. citizenship. Then he's a engineer. He's a genius for the blockchain, as a blockchain engineer, and he wants to set up a company together with another guy. Then I joined as a co-founder and also the chairman when we found Soramitsu. Then Soramitsu joined the Hyperledger Iroha, Hyperledger Consortium. And when 2017, I believe, Hyperledger picked up 3 incubation programs for the consortium blockchain. One is Fabric. Someone has just used the Fabric for the presentation. And another one is Sawtooth by Intel. And the third was Soramitsu's Iroha. So can you imagine that one is by IBM, another one is by Intel, then last one was Soramitsu. And just Soramitsu is just 1 year old company. No one knows about us. And then people start to discuss about who Soramitsu is. Then there's a competition of Cambodian banks, CBDC. And we are fighting against R3. Maybe you know that R3 is very famous for the for the blockchain group for the finance using Quorum. Then Fabric. Then eventually we won. Then we started to prepare one of the world's first CBDC in Cambodia. And the background starts 2020. Then formal started 2021. And now more than 15 million people are using it. And as I just told you yesterday, 80% of the people didn't have a banking account. So it's some difficulty to access to the cash. And that then we have to solve this financial inclusion problem. But because of the backend's release, actually now almost everyone has a digital wallet in your smartphone. And now, together with the Japanese government, we like to expand our CBDC or digital money activities. So now, National Bank of Cambodia is real use case. It's not a POC, but for the POC, we are now doing with Palau, Laos, and Solomon. We are doing this POC, and also we've done a POC in Indonesia with BCA. So these are what we are doing. So this is just the kind of the cashless type of the app, and the Cambodian people can use dollar and real. Real is a local currency. So in one app, you can use both currency, dollar and real. And actually, they are doing very well. So now, number of accounts is 30 million. Their population is something like 16 to 17 million, so almost double of the population. And number of merchants participating in 4.5 million. And it's also a good, big number. And the most amazing figure is actually, I haven't been deeply involved in the backend's development in the last couple of years. So just, I find these figures that I was so, even myself is impressed with $151 billion circulating. And actually, there's a little bit complicated because they are issuing real local currencies, CBDC, plus US dollars. Actually, that is a stablecoin because it's not a local currency. And 70% is in dollar. That means actually their stablecoin, Cambodian stablecoin, is something around $100 billion amount circulating. So that is, I think, it's a really big things. And as yesterday, just we listened what is going on about CBDC in this country, and India is totally two-tier way. But in Cambodia, they are doing both. One is just a single tier. So this is a back-on wallet, so directly issued by Central Bank of National Bank of Cambodia. But others are issued through local banks, and the majority of transactions are done by local bank. So each account holder owned back-on's wallet in your bank. Then they can use either dollar or local currency. This is what is going on. Then also because each bank has a relationship with other banks in like Thailand, Vietnam, or Laos, and Malaysia. So in some countries like Thailand or I think Thailand and Vietnam now, still you can use this back-on apps in Thailand. Then when they send the money back, you can use this app. This is what is going on. And actually, back-on can be used in Osaka Expo, but as far as I know, no use case. Yeah. No. I think well, we little lack of promotion. But just we prepared that one as well. But this is what is going on. And I think there's a lot of discussion about CBDC, and also IMF has just released a report about the concern about stable coins yesterday or the day before yesterday, and exactly the same as what we discussed here. But CBDC or tokenized deposit will create some different pictures. So this is just an introduction of back-on, all right? Yeah.
Fantastic, okay. Thank you very much for the introduction. No, please go there. Good, sit here. This is yours.
This is okay.
Fantastic, thank you. Actually, I thank you very much for the introduction, because actually this was one of my first questions to you, EK, which is, there are these CBDCs, there are these projects. Actually, Bekong actually shows to be a very successful one. However, in a country in which, as you also mentioned, the level of dollarization is very high as well. Did I understand right that large percentage of the holdings inside of the wallet is also in a stablecoin in US dollars then? Did I understand it right?
Yeah.
So is it having a, because now you have half of the population already having this, is it affecting in any way the the economy, but specifically the stability of the local currency, or not at all?
All right. So first of all, why they chose two currencies? I think not only in Cambodia but in many countries, just dollar is circulating everywhere, and of course at first they want to do only the local currency. But if you look at the reality of the economy, if they ban or if they don't accept US dollars, US dollar CBDC or stablecoin, it may not be working. This is what the National Bank of Cambodia thought. And another thing is, dollar is still better than Chinese yuan, right? Because at that time, China, this government has also announced that they are preparing for the CBDC, and also WeChat Pay or Alipay are prevailing all over the Southeast Asian countries, and Cambodian Central Bank don't want to be a situation that everybody using the Chinese yuan instead of local currency or instead of dollars. So that is why they accept to put the dollars in their CBDC program.
Mm-hmm. But is it because I am from Argentina, as you know, my question is, in general, when you have a lot of the savings in a foreign currency, it creates continuously a demand for that currency, which eventually deteriorates the stability of the pricing mechanism of the local one. And my question was whether it had a systemic impact or not at all. That was the question.
Actually, I haven't discussed that subject with the people from National Bank, so I'm not sure. But as far as I know, that kind of the bad impact didn't take place, as far as I know. But in general, that country has a lot of high inflation and instability of the economy. So if same thing happened in a developed country, things will be totally different, though.
Correct. Exactly. Thank you. What is your take on these kind of projects, and how do you relate it with the implementation that you have in India? Because in India, obviously, you have a far larger population, therefore a far larger economy, and then the rupee is not necessarily affected by foreign ones. So, of course, you took your own route in terms of implementing a CBDC. First of all, what is your own thinking on the way in which India has been implementing the CBDCs locally? Yeah. This is the first part of the question. And then I want to bring it also into the global stage. What are the possibilities to interconnect it, and then we go back in this direction to other countries, because payments, cross-border payments, is something that is very important for us all.
Thanks. So just to answer that from a macroeconomic perspective, so the objective of every central bank in the modern era is largely to ensure price stability, and the question about inflation being managed is important, and that is largely achieved through the monetary policy mechanism. So for that, there are several instruments, including the bank deposits and the reserves that the commercial banks have to keep with the central bank is an important aspect of the fractionalized reserve system, and that's how the credit gets multiplied in the economy. But when we look at money as fiat money, as a legal tender money, and this element of trust in it because it's issued legally by the central bank, and when the central bank chooses to have a centralized digital currency in the form that there is a Bank of India, India's central bank has been piloting in the two contexts. One here is in the retail context, the other is in the wholesale context. Now, the pilots mostly would reveal what is the kind of implementation challenges, what is the willingness for the participants to come up with it, and there are around 20 banks that have been participating in broadly these pilots. So the experience largely has been that given the success of the UPI that was referred to in the earlier context and the kind of inclusion measures that the government has been undertaking, the general acceptability is high, in the sense that if I'm looking at this CBDC as a substitute for cash, that's one set of mechanisms through which it can influence the stability and the demand for the relative transaction demand for money as we know it, in terms of it as a substitute for deposits that the economy has from the households and the firms in particular. But the third area, which is a very important aspect, and I'm glad you referred to the IMF report as well, is that if the banks start competing with the CBDC in terms of the reserves at the central bank, then that's going to have a significant effect on stability. And then the second part to your question, Claudio, yes, when we talk about the cross-border transactions in terms of the speed with which it's being done, the security is becoming an important concern, but the central bank's logic has been both the cost and the speed. And we have to think through carefully that in terms of the kind of tech stack that we have in place, is it indeed a game changer? And what are the security concerns that one needs to look at going forward? So that's going to be a continuing conversation here as well.
Thank you very much. How is it that Bekong, because I saw that it is integrated with all the neighboring countries as a payment system, Bekong. You can do cross-border payments as well, and also people from foreign countries. I saw Alipay, for example, there, are able also to just limpidly interact with Bekong. I also saw that you had different countries like Laos and so on in which they were also implementing. Are they interoperable as well?
Actually, as a CBDC point of view, Laos or as a country is just a POC, and it's a kind of the competition with influence from China and from other aspects. So things are not so simple though.
If I am allowed, I was surprised to see you there because I was also expecting exactly the last sentence. Good.
Yeah, but even other countries are not issuing the CBDC, but because of the relationship between the Cambodian local banks and other banks like in Thailand, Vietnam, so they can use a Bekon's wallet through the local bank to like a bank in Thailand or a bank in Malaysia. This is already happened, but it doesn't mean that CBDC is directly connected to other countries or other currencies. However, in southern Southeast Asian countries are creating a kind of group that just the digital money transfer, they make the digital money transfer easy. And I'm not sure, but now how many countries? 7 or 8 countries are joining that kind of the activities. So that is also a kind of the reason. Just these activities doing better than we had expected. Yeah. And another important thing is because you control the money supply and also the local, local economy. But assuming that in the past 80% didn't have a banking account, that means there's a lot of underground money, and also the government or or central bank want to control the money supply in your country. But if you people don't have the banking account, that means other type of the settlement system, such as I mentioned, like Alipay or some Chinese way thing coming in. So they can't control the money supply, and also they can't control the underground money. So that is another reason. Just they want to proceed these CBDC or digital money infrastructure.
Exactly. Also because it happens in a lot of development countries that are developing that basically there are also private actors in non-Latin America is taken by Mercado Pago and so on that basically take over this role because actually it's a financial need of everyone in this digital era to have a correct payment system. I have a question related to perhaps going at a larger scale because and perhaps we're going to start with Sartak on this. All the BRICS countries have been developing their own settlement system across countries that go beyond CBDCs, but it's trying to use their own local currencies to settle payments between them. Can you tell us a little bit about this experience and where do you see it, and whether India is planning to integrate it in some way with the rest of the digital infrastructure?
Yes, so that's a great question. In fact, that's a follow-up to the earlier remark as well, because can we achieve these sort of integration problems and can kind of achieving some interoperability without the international cooperation. So within groups such as BRICS, yes, indeed, there's a lot of learning that has come from the Bank for International Settlements, BIS, where we try to understand, in particularly the project Dunbar, that's something I could refer to, where we understand that one objective of having the kind of broader CBDCs for international cross-border settlements is the efficiency gains, as we talk about it. Correct. And the risk factors are going to be the risk to your monetary sovereignty. Now, if you look at the kind of deeper concerns about the security concerns that were talked about earlier in the day and even earlier sessions in the conference, you'll realize that there's deep emerging kind of consensus that we do not know what could go wrong, given the complexity and the nature of emergence in complexity. The deep uncertainties are there. So there's a sense that we have confidence working together in this closer knit community such as BRICS to understand what's going on, but be also aware that if China is having its CBDC, India is piloting its CBDC, and then what if the other partners are not forthcoming to that extent? So to what extent it's not just a technology solution? Because as I mentioned, the objective being the monetary stability and the inflationary concerns that are always going to be there, the bigger and the more, I'd say, immediate need is figuring out what fraction of our cross-border trade among these partners can actually be converted to CBDCs to understand its effects in terms of stability. But my interactions with some of the policymakers in the monetary policy context is that we have to be cautious, that we can't simply understand that we set a target of 50% of the trade has to be in CBDCs and so on. So we'll take it as it comes. And the kind of advances in the technology, much of it has been presented at the conference also. We realize that there's some confusion about what use case really bodes well for our kind of needs here. And the kind of trade uncertainty that's going to be there is lesser in such cohorts, but you'll realize that as we build the trust, and we try to understand that is efficiency gains worth shifting to more of our business and trade internationally in this context. Because at a macro level, it's also evident that such sort of trade is not necessarily going to stabilize your domestic currencies. So you have to understand that we're learning from what's happened with the kind of US-Mexico kind of bilateral trade and the kind of broader volumes of the trade that's been seen. But now that there is some opportunity with trade wars going around and you kind of consolidate as a group and CBDCs offer that efficiency gain, will go for it. But just to answer your question very briefly, we will not consider this as a binary. So we're going to have that as a combination of the trade-offs that are in.
Correct, exactly. Where it is, so it's better. Please.
May I ask a question? Because you have already launched URI, Yuri or URI?
Yeah.
Yuri. You call it Yuri, right? Yeah. Yeah. And it's really convenient system and
UPI, you mean?
Sorry, UPI, yeah. And the cost is very cheap or zero, right? And fast and safe. While you have a kind of the prevailing system of UPI, and of course now you are promoting these CBDCs, or test, and you've already done 3 years. And how you organize the kind of a relationship between UPI and the CBDC. This is actually I didn't get properly after the speech yesterday.
Right, so that's in fact speaking to Claudia's first question also. You realize that if I want to promote CBDCs for the consumers to use for the day-to-day transactions, for P2 merchant transactions and so on, CBDC is going to be faster compared to the UPI, which is relatively faster. But the larger cash here is in India, which has a large rural sector also, though there's been significant improvement in the tech infrastructure and the UPI is increasingly being utilized, we're still a very kind of cash-heavy economy. So the dependence on cash for day-to-day transactions is still very dominant in rural India compared to urban India, but still globally it's still becoming a leader in terms of UPI.
Still, just I got the impression that because of the UPI and also you have a kind of the, whole citizen get a kind of the, you know, biometrics
Absolutely.
ID type of things.
Yeah.
So now everywhere you can do shopping and cashless type of things, but you think there's still cash dependent economy,
Absolutely.
right? Yeah.
That's there. And in fact, I'm happy that you asked this question. Last year, I teach macroeconomics to the MBA students at IIT. This was a question in the NSEM exams. So when the central bank is launching the CBDCs, what is happening to India's money supply? Now that was a bit of a tricky question. I'm not going to give out answers as such, but the broader idea here is it doing anything to the reserve money of the central bank? Because CBDC is, after all, liability of the central bank.
Correct.
Now, when the central bank wants to really have an impact on inflation management or the kind of money supply that is going to be instrumental here, you realize that I can also tweak interest rates to see whether people are shifting to cash or keeping their money as savings bank deposits in the banks. Now, CBDCs are of two types in that context. They're going to be interest-bearing CBDCs, non-interest-bearing CBDCs. So your question is largely in the context of the non-interest-bearing CBDCs, and that's where there is going to be a lot to be desired in terms of whether people are comfortable having those non-interest-bearing transactions in terms of CBDC or in cash. So that's why the pilots have revealed that there's much to be benefited for the wholesale transactions. And that's where the hint is that for cross-border transactions, CBDCs offer a lot of potential. And given that we're able to look at the risk factors that we talked of.
And is there any intention by the Indian government or Indian central bank to collect cash not in the market, but on the ground, actually, right? Because as far as cash is just prevailing, you can't control the cash amount on the ground. So to issue the CBDC, just collect cash and visible, or make the money movement visible as possible. Is that kind of the intention you have?
The short answer is no. But the long answer is it depends on how we're going to design these transactions, particularly for the direct benefit transfers. So these are transfers which in a common parlance could be considered as helicopter money as we know it, right? So government is dropping money from the helicopters. So that money be dropped as cash or as CBDC would be a good thought experiment. But you realize that the question, in fact, the remark that Claudia you had is what is that CBDC doing to demand in the economy?
Correct.
Right? If it is able to increase what we call the velocity of circulation of money, right? How quickly money is changing hands, then yes, it is going to, given the supply constraints, lead to inflationary pressures. But the challenge is the government doesn't have the intention to kind of say that, okay, it's going to substitute, I want you to substitute your cash with CBDCs. Rather, can they coexist in a manner that we understand how it's evolving to be better suitable for one need than the other. So that's the broad
Talking about which, if you can implement interest-bearing CBDCs, interest could be negative as well, and then you are fostering the functioning of the circulation of money as soon as possible as well.
Absolutely.
And I have a question related to this, and this is perhaps a very philosophical one, so I apologize for this. You can skip it. But to me, it's very interesting, all this dematerialization of ownership that we are facing, and actually also with all these digital ways of storing value, even money, ownership of money has become dematerialized. Perhaps there are countries or places where still there is a lot of physical information, physical versions of the money. However, most of our assets are being stored digitally, but also it is completely different the process by which you can spend it. And this is whether you think that this is leading to a different kind of behavior in the way in which we react on how we spend the money itself.
Sure.
Please.
Go ahead.
It's a philosophical question.
That's actually a really difficult question. Say, if things in Cambodia, the Cambodia's case is a kind of the exceptional case because, as I told you, that 80% didn't have a banking account. Quite difficult to access the cash, and that means in order to get the payment from the company. I mean, company means or your wages. It was quite difficult to deliver the money to employees. That when actually the friend of mine was running the company in Cambodia, And because of the background, they said, oh my God, it's now very easy to deliver the money to the employees. And actually, he didn't know I was a founder of Suramitsu. And you know, Cambodia is now, you know, that's very fantastic. Now it's easy. This is a system we developed. This is the kind of a discussion. And also, at the same time, central government introduced, the central bank introduced the kind of the common API. So once central bank introduced one system, actually, it can be applied for all banks in Cambodia. Because that country was quite behind from other countries. That is why actually it is successful, right? So now they have money in their wallet, digital wallet, and a smartphone. So the way to use the money or a way to shop have been totally changed. This is, I believe. But assuming that it's going to happen in Japan, just paying the cash change to some digital money, I don't think it's going to have a big change. So it's totally different between the kind of the developing countries and also developed countries.
Correct.
Yeah.
Absolutely, absolutely.
Right. So, and to me, it might be not an easy answer because it depends on which school of thought you subscribe to as an economist. Also, advice. If you see that money is neutral, the money supply in circulation is not going to present. In fact, the prices as set by the real value. That's going to be important here. But the kind of broader lesson that I could refer to here is what happened when we started having transactions through credit cards versus cash transactions. Now, it is well known that when you are paying for a certain service or certain demand being transacted through a credit card, you end up paying more because the ease of transaction. So that's a behavioral economic insight also.
Correct.
Because you don't, the loss aversion that you have for cash is very different than the loss aversion for money in some digitized form in a deposit in a bank. You feel disconnected to that money.
Correct.
Now, so that's why the pain of losing or parting with your money is more in cash. So the kind of easy answer in a behavioral economic context is yes, it's going to differ in terms of whether it's in CBDC or in cash. But in terms of the broader implication on the ability of monetary policy to be implemented to kind of change the demand in the economy is what the central bank is worried about. Just as an aside, a few years back, I wrote a paper asking a very kind of bold question, as in, do we need a central bank? Which is largely in a Hayekian sense. But the broader question is, I was not very comfortable with the central bank saying, I want to offer decentralized, distributed ledger, technology-based money. Now, the whole point is that that's some sort of a kind of concern. If you see that, why are we so excited about a central bank saying decentralization elements of technology is important, though I'm not letting go of my kind of ability to control the money supply. So that's where we say if people or private money is being circulated on its own as a theory. FAI has already written about it decades back. But the challenge is the implementation, as you talked about in Cambodia or in Jamaica and Bahamas, to a certain extent, given the volumes of transactions, you're seeing the scale in India is going to be much larger. So it is in that context that we have taken a stance in terms of the ability of the central bank to influence the money supply and the interest rates, largely through the interest rate mechanism, through open market operations of bonds in particular, that the money kind of is in importance. But the moment I have CBDC influence that monetary policy mechanism, central bank could be, in an analytical sense, not comfortable with. So I feel the broader, it's not essentially, if you look at what's happening in the United States, so the kind of Fed is in a context still at a researching position, while China and India have gone ahead to pilot, and while some of the examples you took, they've gone ahead to implement. So to a large extent, our policies internally, if you see how the central bank could think through monetary policy, is closer to the Bank of England than with the Fed. But we are still so influenced by the expectations about the future. That is largely the signals that the Fed is doing, even the US labor market expectations and so on is going to influence. The CBDC is still a small fraction, even if it is going to be implemented in whatever form. But the kind of lessons have indicated that there's a greater interest in considering it for cross-border transactions and not much for the day-to-day transactions. And the point that you also indicated, well, what does the private sector do here, right?
Yeah.
And who has access to the CBDC?
Correct.
How do you have the access to the CBDC?
Not only digital money side, but also like a DX or a contract or a ID verification, like smart contract, AI agent. These type of things are actually in one basket. This is, I believe. So even money is digitalized like a CBDC or a tokenized deposit, but making agreement on a contract or send an invoice. These things are not digitalized. It won't change. But these things will gradually or maybe quickly change. I think simultaneously. In that case, I think the CBDC will be more important because the digital monies, I don't know, good point or bad point from whom you are thinking it to be different. But good point is to trace the money movement.
Correct.
Everywhere, right? Yeah. So if each, commercial transaction, not necessarily commercial transaction, but also some governmental transaction or governmental activities will be digitalized and monitored. The money should be monitored as well. In that sense, I think CBDC has a lot of sense. But in order to that, you need a. Is that all right?
Yeah, no, it's fine. I wanted that.
Okay. You need you need a kind of
privacy.
total development of these digital transformation, I think.
Correct, exactly. And just to conclude, then, can you please share? You were starting to. This is basically the spirit of what you both have been thinking of, the perspectives of CBDC. Where we will be then in a few years from now? And perhaps we're going to have different stories. Perhaps in some countries it will become a tool for allowing for better remittances or inter-border payments and so on. In some other cases it may be just full digitalization. Country that Japan has been leading digitalization for 40 years, perhaps going to be different. What will happen then?
Yeah, so on a lighter note, because we're in IIT Bombay, everybody wants to talk of AI and some of the other. So one thing for sure that I can visualize is there's some interest in how AI can be brought in the CBDC in different contexts, be it discoverability or having the FAIR principles figured out. But we have to pay attention to the broader objective of the government of India as well as the central bank, and you referred to that rural kind of urban divides, is we cannot really let go of the financial inclusion objectives also. So to what extent CBDCs are playing an important role in achieving the financial inclusion goals of this government of India as well as central bank in that sense is important. And as an academic, what I could also foresee is a lot of research in revisiting the questions of independence of the central bank in terms of its ability to decouple the CBDC decisions from the objectives of the fiscal side of the government. Though in the broader sense, if you understand the structure, so that in practice the independence is not going to be, but in principle, in theory, in monetary economics, that independence is important, and the international capital flows. And because we still have not fully converted our capital account, and that's something we have to be careful about. Correct. So because you can't just convert a dollar to rupee and vice versa in the open market. So there is a lot of progress gradually towards partial convertibility. The degree of it is going up, and that's where I see a lot of potential for CBDCs. But there's enough food for thought in terms of how the technological aspects, the stacks could be developed, and we bring in more efficiency, and what are the other use cases competitive in interspecies money as CBDC transactions. So I would be not surprised if we take it up recently. But there is optimism, but there is a lot of caution in going forward.
Correct. Thank you. Okay.
Yeah, as all of you know that or EU or the European Central Bank has declared that they're going to start a CBDC by 2030, right? Yeah, and I think I'm so rather surprised because I understand they are investigating if they should do or not, but it's the conclusion that they will do it. And as I mentioned, like Cambodia or like some, Southeast Asian country, the financial infrastructure is not solid, and also there's some difficulty to access to the cash. I think CBDC plays very important role. Yeah, but in the developed countries, especially like Europe, financial system has been well organized and prepared. I'm not sure CBDC will be quite effective. But the same thing happened in like a GDPR or EIDAS in a data, data transportation because they start GDPR or DPP, digital product passport, and EIDAS, just EU citizenships, identification. So I think same trend is going on in the EU side. And I'm not sure it's going to work or not, but if European Central Bank's CBDCs goes well, I think that other countries, other developed countries will follow. Yeah, this is what I'm thinking.
Okay. Thank you very much, Ike. Thank you very much, Sarkhan. Thank you very much for staying here, people. Let's give an applause to this.
Thank you. Thank you. And thanks a lot
very much.
Thank you. And we can go now for the final lunch. Yes, exactly. The last super.
Okay, good. Thank you. Actually, I haven't exchanged card yet, right? Yeah. Thank you.
Thank you.
Thank you.
We have a photo.
Photo?
Yeah,
Photo. Yeah. Okay.
Good afternoon. So there will be 3 talks in this session. First by Sagar on dynamic profiling of cryptocurrency wallets, a multi-layered machine learning and graph theory model for security and regulatory insights. Sagar is from DJ Sanghvi College in Mumbai. Welcome.
Good afternoon all. I am Sagar Kurde and I am going to discuss my paper and work about dynamic profiling of cryptocurrency wallets. This is a multi-layered machine learning and graph theory model for security and regulatory insight validation. So this will be my outline of presentation. So as we all know, Bitcoin provides a transparent ledger of all the historical transaction, but there is one anomaly, or what we can say, the no user is directly connected with the transaction. That's why it is misused by the malicious actor, and that is a major problem, and we are going to address that using our proposed solution. So this solution is going to talk about how we can analyze the transaction. Basically, we are discussing about the proactive approach. Okay, so most of the time what happen today, when something happen and then it is get investigated, so we are going to talk about how we can proactively assess and assess all the cryptocurrency wallets. So this is a blockchain anonymity paradox. So criminal exploitation, so money laundering, ransomware on darknet market, terrorist financing. In this particular area, Bitcoin is a primary asset used to fund. Okay, and the current limitation of this area is we have all the investigation approaches of reactive type. So something went wrong and then we start investigating the thing. Then pattern recognition system fails at the scale as the data, that ledger is very huge, and to handle that we will require the huge computational capacity, and due to absence of that in most of the cases, it is difficult to scale at the level where we can say it is a truly dynamic and proactive. So the real-time, limited real-time detection due to again the limitation of this hardware and computational power. So the critical need, today's critical need is proactive, transparent and scalable profiling system. Okay, so a problem statement is we are aiming to develop a comprehensive dynamic model for systematic profiling of cryptocurrency wallets and transaction, enabling accurate categorization and behavioral tracking. Okay, so we are going to use 3 different approaches together to identify this. So clustering, graph properties and outlier detection. So the proposed solution. So this is a methodology overview of how we collect a data and how we visualize it. So the first module is data ingression. So extract transaction from blockchain nodes, different APIs, some publicly available data sets, some data sets, labeled data sets from Kaggle and all, everything we used together. Then data engineering, so clean, normalize the data for avoiding the further anomalies, ambiguities in data for further processing. Then the third most important module is analytical core. So where execute 3 layers as we discussed earlier. So graph matrix, clustering and anomaly detection using outlier. So visualization, then the different dashboard created using Python and all other means. So this is our novel architecture. So basically I am a co-PI of this Euclid sustainable blockchain lab also. So we design our own architecture. Currently GPU and CPU miners are working, and we collected all this data using this architecture. Apart from this, this is my data pipeline, okay, as we discussed. So I collected from the core node of Bitcoin, then the different APIs, then it validate. Then in stage 2, extract the required features and created a data set for further processing. And then stage 3 is about a graph and cluster formation that I'm going to discuss mathematically also. And then in stage 4, the visualization of whatever we mine from it. Okay, so this is a raw profiling model where the first is data ingestion layer as we discussed, then the graph construction layer, dynamic profile engine, okay, then machine learning layer, visualization reporting layer, and feedback loop. If we found something, if we can train again our system according to this, we will get better result. Okay, so using Bitcoin core, we collected total 12.4 million transactions. So basically 10 engineer features we use. So based on temporal, transactional volumes, network positions, and behavioral signatures. Then 20 odd unique wallets we identified. Okay, so 3 complementary layers we use to do that, combining graph, unsupervised learning as we discussed, and outlier detection. Then it required 4-hour time span. Okay, so 5 stages from raw data to the fair data set. So it is after collection the raw data. So feature engineering frameworks. So we are working on these 4 types of features: temporal features, volumetric features, graph-based features, and behavioral features. So basically the temporal feature is used to capture the wallets operate and how their limit deviates from the normal pattern. Volumetric is for the identify unusual large movement and suspicious accumulation patterns. And the graph-based features we use for reveal wallets that serve a hub, bridges, or isolated actor from the transaction network. Then behavioral features, so detect mixing behavior, tumbles, and operational security patterns. So the note is all features undergo standardized using a robust scaling and handle outliers, followed by AHP, that is analytical hierarchy process based weighting to reflect the investigation importance. So this is my total risk formula. So where we can calculate risks based on all 3 parameters as we discussed, based on cluster risk, graph centrality risk, outlier risk. This is a formula. So basically we are using AHP as we discussed. So it is assign a specific weight for every lambda here. Lambda C stands for cluster risk, lambda G and lambda O. Okay, the further alpha D GD, this shows in the equation 2. So let me explain throughout equation. So here lambda C shows a weightage of cluster risks in this particular formula. Then this B stands for the bad wallet, okay, and this shows a relation with the bad wallets out of the all wallets. Then lambda G shows a weight of graph centrality risk, okay. Then alpha D GD, this is assigned with the centrality coefficient, then the betweenness coefficient, and then the page rank coefficient GP alpha P is for that, and then this lambda O stands for outlier risk. So here you can see there is a certain weight assigned. So 0.105, 0.25, 0.36. So basically if you add this, it comes to 1, and we are going to calculate our total risk score out of 1. So further I am going to discuss in coming slides. Okay, so first upon, why we are using analytical hierarchy process, okay, in an era of basically data driven things. Okay, so basically in the data driven approach, we can train our system with the data, and most of the time we don't get control, or if one out of the box pattern come to the picture, and if you want to use any expertise or the knowledge of any expert from the domain, so that will not be allowed by the data driven most of the time. In analytical hierarchy process, we can assign a weightage according to the requirement. So here in our formula, okay, as we discussed earlier, so the outlier having the highest weightage, then comes graph risk weight, that is 25%, and then the cluster risks means due to the communication or the association with bad wallets, it is the lowest here. So it is based on the literature survey. So how AHP decide a weight? So it is based on the matrix. This is a adjacency matrix formed between the cluster graph outlier, okay, and it compare one particular feature, how much this feature is important or it impacted the overall calculation. Okay. So risk classification threshold. So based on that formula, if we get a value of yes, the greater than 70, then it is a critical. If it is between 50 to 70, or means 7, so it is the orange. So priority review recommended. Elevated risk score. Okay, so we can take this for the further investigation. Then 0.3 to 0.5, that is LO, so standard monitoring protocol, we can apply over that. And if it is below 30, then it considered as a normal, or we can apply again a standard measures. Okay, so during all this stuff, okay, I learned so many things. So we started with the very first step, that is collecting data. So the major challenge started from here itself, how to enable Bitcoin core that is so much resource heavy. Okay, so we enable this Bitcoin node first, and then collect all the data. I already told you the transaction number and the volume. So this is a data set, okay, that we pull from the Bitcoin directly, Bitcoin core directly. So these are the different attributes, and 10 odd attributes we use for the further study. So based on that, after collection of data, we labeled some wallets. So this is not a real picture. We just try to simulate on the limited wallets and how k-means will show these clusters if we consider k equal to 4. Then how dbscan show us if we consider 2 samples and epsilon equals to or radius is equal to 1.4. So these are some images. Then the most important part, when we work with this Bitcoin data set, so data set is very huge. Okay, most of the time what happen if you are running any particular Python script or JavaScript, so it will take huge time and it is again limited to that particular session. If we end the session, then we lost throughout progress. So then we introduce in between this Postgres database to store the context of some query, so we can again start from the where we stop. So this is not integral part of my architecture, but yes, we are using this to store the context. Okay, this I tried to visualize a data set, the raw Bitcoin data set of only 1 day. So this much noisy output you can see. Okay, so this is then further I tried to investigate one particular wallet for 1 day. Okay, how much transaction one particular wallet can do with the other, or usually perform. I will show you at the end of this presentation the real instance of this. Then I come to know after this work the hybrid approach is performing better, as the Silhouette score is better in case of hybrid if we combine both k-means and dbscan. So I reserve some result at it is remain for validation, and then Davis bolted index is lower in case of hybrid, so means we are on the right path as far as the literature services. Again, I tried to form one adjacency matrix between 5 wallets from this data set, just for observe what type of adjacency matrix I will get. So here you can see from 0 to 16, this temperature shows relevance of wallet, means transaction, volume of transaction between volume and iteration between the 2 wallets. So key research finding is the comprehensive study over this cryptocurrency profile reveals a significant advances in both detection accuracy and interpretability, with measurable impact across the multiple dimensions. And it stated how proactive approach will reduce a challenge of misuse of by the malicious actors. So this is a future scope, real-time detection. As we discussed, this is very challenging. We will require a complete cloud-based system if we want to move on the real time, and again the API cost and all other. Then the multi-currency framework, if a multi-chain, if we think that is again a difficult task, because every cryptocurrency use a different fundamentals and their different attributes. Then explainable AI enhancement we can introduce into it, and then temporal dynamics modeling, also the one direction in which we can work. So in conclusion, wallet profiling in blockchain requires the integration of advanced storage and computational techniques, as we discussed, because this is very huge, it creates very huge data. So first of all, the enabling a node and then downloading data and then processing, means we are talking about 3x of resources as far as storage and computational resources is concerned. So then to achieve practical and scalable profiling, the dynamic network analysis, real-time transaction tracking and online learning method is essential. Okay, so by addressing these challenges, it comes possible to develop robust and the dynamic framework, real-time framework. Okay, these are some references that I've gone through. So thank you. If any question.
Are there any questions? So let's thank the speaker.
Thank you. Thank you very much. Oh, okay. One thing. Okay, so this.
I have.
This is a one particular wallet. This is a core wallet. Okay, across this wallet, I try to identify. So here, if I click, so you will see the amount and all. Okay, so it is difficult by this process. Just I am showing. So we have done this also. Okay, thank you.
How did you plot this? Quite interesting.
Using Python. Yeah.
Okay. What libraries?
Network X.
I see.
Yeah.
Good.
And PY visuals.
Okay.
Yeah.
Okay.
Thank you.
I have one query.
Yeah.
Regarding your slide number 24.
Yeah.
Yes, that is second thing was while war is a bitter. The second graph. Here written is a
evaluate cluster separation quality. Okay, so hybrid achieve the lowest. Okay, demonstrating the superior cluster distinction. So it actually shows a distinct cluster if the number is lower, and if the number is greater, then it is somewhat hazy cluster will get. That's why the lower is better. In that case, higher is better. So solid score analysis.
What is the difference between these two analyses?
So basically, this measure cluster cohesion. Okay, where you will require a connection between multiple wallets with one particular wallet. Okay, so it shows that quality of coherence with the different and this is showing a quality of separation. Okay, so we will require, if we are creating one cluster, that should be dense and that should be isolated from the other cluster also. So these two distinct things showing distinct properties.
Okay. Yeah. Is it any reference?
Yeah.
Okay.
Yeah.
So next one, slide number 13.
Yeah.
Yeah. You will take this value 0.105.
Correct.
So why choosing this type of value?
Yeah. So it is again based on the literature survey. Again, the beauty of this AHP is if you want to calculate something, like if some particular case come to investigation, okay, and if you want means if experts suggest you in this particular case we have to calculate this with the different weightage, so we can do that. So this also came from the literature survey standard. So but this is approximate, this is not fixed.
Okay.
Yeah.
Okay. Thank you.
Yes. Thank you.
Let's thank the speaker once again.
Thank you.
So our next speaker is Ilya Donhauser. He is going to talk about XRP price prediction via recurrent neural networks. Welcome, Ilya.
So thank you for introducing me. I'm Ilya Donhauser. I am a researcher from Kyushu University in Japan, and also I'm associated with another university, La Trobe University in Australia. And first, it's a pleasure to be here in India and see how people work and live here and how everything is organized here. But amazing experience. So I'm going to talk about our ongoing research with Professors Pierluigi Cesana, Tomoyuki Shirai, and Yuichi Ikeda. And this research is about predicting XRP prices using recurrent neural network. Cryptocurrency markets can be highly volatile. In certain weeks, prices of cryptocurrencies can skyrocket or fall down very quickly. And predicting those extreme events on cryptocurrency market is quite important in terms of devising efficient investment strategies and also in terms of providing market stability and transparency. But it's also quite important in terms of broader adoption of blockchain technologies. So in our research, we focus on XRP price prediction, but we pay a special emphasis on anomalous price movements when prices are going up or down very fast. In standard prediction methods, when the goal is to predict the trend of cryptocurrency price, people quite often use standard market indicators. And those market indicators can include trading volumes, average number of transactions per user, like price and price increments, and also people quite often use features describing the sentiment of the market, what traders think about the behavior of the market. But unfortunately, those features do not take into consideration financial network structure effect, how people trade with each other. So what are the relationships between people on the financial market? So in our research, we go further and we study the structure of XRP transaction graph. And the goal is to understand how certain features of that transaction graph can be used to predict anomalous price movements. I think in this audience, people are familiar with transaction graphs, but just to mention it, you can think about XRP exchange market as a weighted graph, where nodes are wallets, edges between nodes are transactions, and weights of those transaction amounts are, weights of those edges are transaction amounts. So here you can see visualization of XRP transaction graph for transactions from 1 week. This visualization was prepared by another young researcher in our group. So here in this visualization, each dot is a wallet. And I'm not sure if you can see, but there are also connections between those nodes. So those nodes, they represent transactions between people. And our goal is to study the structure of this transaction graph and find certain features that can be used to predict anomalous price movements. So in order to study the structure of transaction graphs, we actively use topological data analysis. TDA is based on methods from algebraic topology. So algebraic topology use methods of algebra, like theory, group theory, to describe shapes of complex bodies or topological manifolds. And then topological data analysis use methods from algebraic topology to perform advanced data analysis of complex data structures such as graphs. So we use the following tools from topological data analysis to study the structure of transaction networks. So first we use persistent homology. Persistent homology allows you to track how topological features, such as connected components and cycles, appear and disappear in the transaction graph when you change the filtration level of your transaction graph. Then Betty numbers allows you to summarize number of those features at different scales, at different filtration levels. And also to further analyze the structure of the transaction graph, we use motifs that are small recurring subgraphs. And by counting how often those motifs appear in transaction graphs, you can describe the topology of that graph. So before I start talking about how we apply this to our transaction graphs, I would like to show you how these topological instruments work on simple toy examples. So suppose that you have the following transaction graph, and then in persistent homology we have two axes, birth and death of topological feature. So if the filtration level is less than 1, then all these weights are greater than 1, so we cancel them out, and we have 4 components in our graph. And once the filtration level achieves this value, then B is connected to A. So we have B disappears as a separate component. And then you can see in persistent homology there is a point with values birth 0 and death 1. Then you increase the level, and then C disappears as a connected as a separate component, and then D separates as a separate component. And once you increase the filtration level to this value, then you have a cycle. And this cycle is denoted by this orange point here. So this orange point has death value 2, but in reality it's just the maximal value in our persistent homology. But this cycle never dies. So you can also construct persistent homologies in Python using library Ripser. So the persistent homology of real transaction graph is much more complex because there are more nodes and connections between them. And in persistent homology for transaction graph, there are 2 clusters of topological features. Those who appear and disappear very fast, but there are also cycles that live forever. You can also use a discrete version of persistent homology when you take all transaction amounts and you find percentiles of those transaction amounts. And then you can filter your transaction graph using those values and calculate how many connected components and cycles you have in your transaction graph. And those values are beta 0 and beta 1. And then you can track how these values evolve once you change this filtration level. And in what follows, we will be using this approach instead of persistent homology. So to further analyze the structure of the transaction graph, as I have already said, we can also use motifs, small subgraphs. And you can see how often those subgraphs appear and disappear in a transaction graph. So we looked at different motifs, but we paid special attention to these 2 because appearances, frequencies of those transaction graphs or of those motifs are correlated with the actual XRP price change, and that correlation is statistically significant. In Python, you can find frequencies of those motifs using package networks and then command isomorphism. So we also decided to devise a quite simple approach to measure the sentiment of the market. And we used it using Google search trends. So by measuring how often people Google certain words, you can understand what people feel about the market. And we found that frequencies of Googling words like Democrats and Republicans, they are quite correlated with the actual change of price. We tried to see how often people Google XRP price change, XRP price increment, and so on. But usually people Google those things only after actual change of price. So it doesn't give you much information when predicting XRP price. So our data is as follows. We have data from 208 weeks, ranging from October 2017 to October 2021. And for each week, we have 3 groups of predictors. So the first group is market indicators. And the second group is topological features devised by topological data analysis and obtained from transaction graph. And we also have sentiment feature, the later sentiment feature. And our goal is to predict XRP price increment in the next week. So to be more precise, we have the following variables in our data. We have XRP price at the end of the given week. We have XRP price increment in the given week. We have total trade volume, like how much coins people send to each other. We have how much total trading volume for top 1% of the most successful traders. So for each week, we found the most successful traders in terms of their historical returns on the next week and how they buy or sell coins in a given week. And then we look how these people trade in each week. And we also have 2 features that are from Bitcoin, and they are also market indicators based on coefficient which is called pure multiple. And then we have our sentiment feature. We look at the increment of this feature. And then we have 3 features taken using topological data analysis. Motif 1 increment, motif 2 increment, and then we take Betty 0 filtered for the graph with a percentile 40%, and we take increment of this value. So you can see that all these features, they are statistically significantly correlated with the target variable, which is XRP price change in the next week. But topological features, motif 1 increment and Betty 0 increment, the correlation is quite strong compared to the correlations between the other variables and the target variables. And even if we consider a more robust ways to measure correlation, like Spearman-Rho, still those topological features, they are correlated, and those correlations are significant, statistically significant. So our training procedure and our model are as follows. We take first 130 weeks in our data as a training set, then 40 weeks as a validation set, and 40 weeks as a testing set. Unfortunately, you can see that the XRP behavior in the test set is quite different from validation set and test set, but we don't have any other data. And then as a model, we use long short-term memory neural network. We use it because it can handle long and short-term dependencies, but it also can overcome problems like vanishing or exploding gradient. So you can see the performance of our neural network here in orange color, and in the blue color are real increments of XRP. So our model was not very successful in predicting this spike. This spike was quite a serious event. Probably it was caused by a positive core decision in favor of XRP, and it also was probably caused by some political situation like change in the United States. But our model was able to predict the aftershock and also some other extreme events in XRP price change. So our main question is, do topological features really carry important information about XRP price change, especially XRP price anomalies? And in order to answer this question, we use Shapley values. So Shapley values, originally, they came from cooperative game theory, when players cooperate together to achieve the result. And then you can measure the contribution of each player in the final outcome. So in machine learning, you can consider all the features as players, and they cooperate together to give the result. And then you can measure the contribution of each feature using Shapley values. So our methodology is as follows. We first mark by red dots the weeks with the following anomalous XRP prices. And then for each week, in each feature, we calculate Shapley values. And then for each week, we rank features according to their Shapley values. And then we calculate the average Shapley rank for each feature in anomalous weeks and in usual weeks. And then we retrain our neural network a couple of times to make sure that there is no randomness coming from training procedure. So here you can see average Shapley values of features in anomalous and usual weeks. As you can see, topological feature Betty 0, it has the highest average rank in anomalous weeks, and also another topological feature like motif 1 increment, it also has quite high average Shapley rank. But in usual weeks, all those features, they have almost the same, roughly the same average Shapley ranks. So our neural network, it relied a lot on these topological features when generating predictions for anomalous weeks. So in conclusion, we can say that transaction graph structure carries important information about XRP price change, which is evidenced by high correlation between topological features and the actual XRP price change. Neural networks can model relationships between those topological features and price change. And also, like neural networks rely a lot on those topological features when predicting anomalous XRP price change, which is evidenced by high average sharp ranks. In future, it would be quite interesting to study other properties, topological properties of transaction graph, and see how they can be used to predict XRP price or other cryptocurrencies price. Thank you. Please let me know if you have any questions.
Yeah, let's thank the speaker. Are there any questions?
Hi, thanks a lot. It's a good presentation. My fundamental question here is that you assume that markets are rational, right? Because these modelings work on rational data. But in my opinion, say if there's tomorrow a news event, market could behave irrationally. Do you think that these models will be able to fairly perform or model that kind of information? Thank you.
Well, that's a hard question because so the question is transaction graph topology, is it stable over time? And it's a quite hard question, and I'm not sure how to answer it. So we can see historically that if we build model on some data, then still model can predict prices in anomalous weeks. So still there is some, even if so still model is able to use this information. But who knows, maybe it's hard to answer for me this question, yeah, sorry, because it's mathematically quite complex to check stationarity of topology of these transaction graphs. At least like we haven't done it yet. Yeah, so thank you.
Any other question? So Ilya, if you remember, we had a discussion over the coffee.
Yeah.
And we discussed that one cryptocurrency follows the other one in terms of volatility. So you mentioned in your conclusion that the transaction graph is responsive, it allows you to predict the things, right? So by correlation, can we say that if you find something in XRP transaction set, we find the equivalent transaction graph in Bitcoin or Ethereum? Would that be?
So there are papers about Bitcoin where they also use topological features, and they also showed that topology also plays important role in in Bitcoin, and they also used Betty numbers like we use. So they just took a lot of Betty numbers and used those values as well. So it looks like for Bitcoin you can also use these topological things too.
Okay, good. Thanks. Thank you. So we'll go to our next speaker, Yashbir from Makeflow, and he's going to talk about permission blockchain-backed federated learning for smart city, traffic sensing, or latency, privacy, accuracy analysis.
What do you need?
Yeah.
Connector.
Does anyone have connector? Which one? Type C to HDMI?
Yeah,
Type C to HDMI.
Yeah, thanks. You said it for me. Thanks.
What is the charge? Are you charging? No? Free?
So I'd like to move freely up so I can have another mic, but then I have to switch. Yes, thank you. Maybe you can turn this off. I have this. Open कर दीजिए. Hi everyone. I know sessions after lunch are a little difficult to accommodate, but I'll try and keep it engaging for you guys. Myself, Yashbir. I am an engineer by profession, and I happen to collaborate with a couple of researchers from my college. College days, so I've been knowing these guys for 15 years. All the implementation questions, you can route it to me. If there are any fundamental questions on equations, I'll find your guy. So my topic here is very relevant. Yeah, so these are the authors. I'm at the last, of course, Yashbir. So a very age-old problem, especially for the metro cities like Mumbai, Bangalore, Delhi, is none other than traffic. And this is a thought experiment where we wanted to solve this problem with whatever capacity we have in terms of technology and the knowledge. And we pondered over that if we can use AI to model the traffic patterns, maybe there is a solution which we can ponder over. You never know, right? AI can find a solution to this. But then when we started thinking or ponder over this thought, the very important point came that all these cameras, they are installed at various points in the city. How will they transfer the data or make sense? So if you have a centralized model, how will that model make sense of these data, right? All the cameras which are collecting. So let's say there's a camera at Rajiv Chowk, for example. It is detecting traffic at 12 p.m. How will that data be sent to a central server? Let's say that we have a model centrally. The problem will be that if it crashes, the whole system is going to fail, right? Again, for a city like, metropolitan city like Mumbai, you can't afford that, right? One single failure and whole system goes down. Maybe there are engineering ways which can handle backup, redundancy, etc. So we started looking into what can we do more. So the next thought came to our mind, can we use a blockchain? Because again, it's a distributed technology. It will have a better fault tolerance. It will also have a better proof of concept, especially around storing and updating the blockchain data. But the problem was latency. Because storing these huge models, if you are going to send everything to blockchain, it will be introducing a lot of latency. So traditional approach might not work for us. And then classic trilemma. I think everyone who's presenting on blockchain does refer to this term. And we were really facing that because if we use blockchain, latency will be there. If you're going to send the data from the cameras directly to the blockchain, store it, privacy will be our concern. And if we try and fiddle around with data, introduce some kind of noise, then the accuracy will impact. Traditional, typical trilemma we were facing here. So a little more thought about, and then a lot of my colleagues from the college, Pankaj and a few other folks from Japan, then we collaborated and started pondering over how we can approach this. So these were the fundamental things which we're looking. That cameras should train their model locally so that we don't have a central server. Only the model's hashes go to the blockchain. So we use on-chain and off-chain concept here. Again, not pretty new. If you're a blockchain enthusiast, you know that this is one of the choices when you're modeling a large application at scale. So full model stays off-chain, only model hashes go to blockchain. And then we'll have to have some kind of consensus, right? Because if you're going to use each and every, so problem with public blockchain will be that all the participants, or at least the majority of them, have to agree on the updates, right? That could again slow us down. The previous slide, the trilemma, right? So we thought, what if we can do something like PBFT, where we have a Byzantine fault tolerance. I'll come to that term again, Byzantine fault tolerance. Maybe we can check for a consensus, and then to make sure that the city data is not personally identifiable, let's introduce some kind of noise. So these things we're looking into while we're designing the solution. So yeah, result was that our model. So again, this was done in a SimCity simulation. We were able to simulate this solution, and what the result was that it was fast, it was private, and it was accurate. How? This is the architecture. Please take a moment, see if this makes sense to you guys. Right? So you'll have vehicles, sensors, a federated learning aggregator, lot of validators. These validators could be the private entities, say government agencies, the traffic control department being as a validator, or maybe some key key personnel in the government can act as a PBFT validators. Then you'll have an off-chain storage and an on-chain ledger. Yeah. On the implementation side, we used Hyperledger for the blockchain, and then SimCity for the data tested. Then we simulated it on WAN with 100 millisecond network latency, and for 20 clients we did this. And these were the results. We were able to achieve around 91% accuracy, fast, 500 latency, 40% reduction. And since this was, again, PPFT was implemented, we were also safe against 20% of the malicious client attacks. These are some of the results. One interesting point to note here is that I would like you guys to focus on this particular chart, which says that more training rounds, the accuracy or the training loss will happen, right? Like it will come down. The more you train, so it's again efficiency versus your accuracy, right? So more you train, the loss is going to come down. That's very interesting to note. And then these are some of our benchmarks. Yeah, I think makes sense. So in summary, using federated learning, so the first concept, everything remains local. All the cameras, they train locally. Use permission blockchain to only store the hashes, and then use differential privacy, where you introduce the Gaussian noise so that the data is not personally identifiable. That's it. Thank you. So I'll take questions around these concepts, right? If you guys have understood the concept, I'm sure there'll be a lot of questions, right? Because I just said it's a thought experiment, and being an engineer, I was involved in the implementation of these things. So happy to take your questions. Thank you so much. Thanks.
Any question
Sure.
you have?
Yeah. This gentleman. Yeah. Yeah.
Yeah, because this is too quick, so maybe if you don't mind explaining each graphs, that would be helpful.
Yeah. So let's focus on the first one. So when we say that we are going to introduce the noise, right? Say we introduce, so we use Gaussian noise here. So that value ranges from 1 to 10. So let's say we introduce a noise of 10, which will be like everything which cameras are sending to the model is absolute noise. In that case, your accuracy will be like completely low, right? Just on the first one, right? The model accuracy will be extremely low. And if you're going to only send that epsilon value as 1, then it is on the right-hand side of the graph. In that case, your model accuracy will be very high, but the data will be identifiable, right? It won't be masked. So the sweet spot which we found in our simulation was that if you keep a noise of level 2, it was a sweet spot where we were able to get an accuracy of around 91% with an epsilon of 2. That was about the first graph. The second one talks about the BPFT concept which I talked about. So here, these are the private nodes. So we are not going to use the public blockchain ledger where each and every node can come and verify the hash, right? Here, what we'll do is only the key members, right? Say, for example, police department of the city will have the nodes to actually verify the proof, right? So the more, so here, if you say the more number of nodes, the accuracy is going to be very high, right? The 90%, right? Around 91% of the accuracy, around that level. This I already explained. This is again around the training rounds and efficiency, which means the more you train the data, of course, the efficiency is going to go very, very natural again here. These are some of the comparisons with the traditional native blockchain. For example, here, in the slow WAN around 100 milliseconds, acceptable threshold, we were benchmarking for the 500 ms while we were training this model, right? So it was fairly, I would say, just at the brink of 500 here. And oops. Slip. Yeah, it's there. Right, and again, this is the so all of this is is a simulation on a SimCity data which we got, and then we just trained this model to find these optimal parameters.
Thank you. Yeah.
Thanks a lot.
So I could not understand what are the privacy concern in the traffic data.
Right,
Is
so-
it like here how many cars are getting accumulated in front of IIT signal?
No, so when you have a camera sensor, so it is an analog system, right? So maybe it is taking the photos, and maybe in the photo when you're taking it, the front people's the vehicle number might be visible.
But that's straightforward. You don't need to store.
But then while we are sending this
Why,
data,
why that is important in traffic
Correct.
analysis?
Correct.
So unimportant things you can scrap there only. That's easy solution.
Correct.
It will reduce the even the volume of data that you need to transfer.
Correct, makes sense. It might make sense, yeah. So like I said, this was our approach of solving it. Like you mentioned, we can use an OCR layer where we can identify if a pattern matches with the standard number plate, right? We can skip that data, very much possible. Yeah. Correct. No, they
car
which car
or
was.
something.
Yeah, makes sense. Absolutely. That'll be all?
Yeah.
Thank you so much. Thank you so much for your time.
Thank you. Is Tejas here? Come. So we have slight change in the program. This author has not turned up, so we have 20 minutes gap, and our tea has not come, so there is no point in having the break. So let me prepone one of the events from the next session here, which is the hackathon presentation. So we have one team online and one team in person. So let's have the presentation, and then we'll have a break. So Naresh, hi. So Ripple team is here. Let's welcome this team. Yash, Rahul, and Naresh. So you can come in front. These are the jury members who have helped us filter out the teams, and with their some little bit of support, the teams have further improved the projects. So let's see what the teams have to present now. So he is Yash. And what was his credit? Tejas. What was his project's name? Credit. Yeah, credit something. Okay, I forgot. So. Do you see the screen online? Professor Shyamsundar, do you see the screen? Hi, Wen, are you online? Do you see our screen? Hello? Mute? Mic to mute hai. Okay, let's go ahead.
Hi everyone, sorry for delay. Myself Tejas Mati, and I am today presenting you Credit Trust, a decentralized credit and reputational protocol with a credit card. So current traditional credit market is fragmented. So currently like we have several credit bureaus. In India there is CIBIL, Experian. In USA there are others. But you suppose a person has a good credit score in India, that will not useful in USA. That is first point, isolated system. And there is no global truth. There is no way we can universally acceptable credit score. And due to several 1.7 billion people have not any credit score, so they are excluded from the current banking system. And in terms of credit on DeFi, we can't. There is no credit score like a system in the current our blockchain. So we are building a system that allows to build a credit score based on deposits or collateral, and in that it's just like offering via a secure card, just like our normal traditional banking system. So in DeFi credit sector, to offer a loan, to get a loan, we need to some over collated thing need to be deposited or need to be lent. So what we are building? We are building a credit trust. It is a credit score protocol plus offering a credit card based on collateral. And if a credit score is good, then we can offer secure unsecured credit card. So first of all, what we are credit score is a decentralized and globally accepted. And second is any companies, suppose we are credit score generating on based on metadata in the blockchain on the ledger. That can be portable credit. Any company can use that credit to offer a loan or anything. And it under collateralized based on suppose someone has a good credit score based on blockchain, we can offer a lending some loan, and it's built on XRP. XRP is the fastest, and it is a finance blockchain. So our decentralized scoring based on similar like our traditional credit bureau use that model. It is Pico compatible model. It is developed by several companies, like a civil TransUnion. So current FICO model is 35% depend on payment history, credit utilization, account age, credit mix, and consistency. Similar like our blockchain model, our blockchain protocol similarly depend on these parameters to generate a credit score. So we offer generally two credit card. Means first is secure credit card, which is some user need to deposit amount X amount, and we offer 100% limit on that amount. So suppose user spend amount, then he need to repay same amount in a X duration period. So on that basis, we can then his metadata generated on the blockchain for the repayment, and that basis we will generate a credit score. And second option, unsecured credit card. Once secure card based on once credit score is developed on the secure card, then we can offer a unsecured credit card. So for unsecured credit card, we have some we generally taking some money or borrowing from the lenders in for that. So so for the unsecured credit card, and we are taking some money from the lenders. So how can we return them in terms of API? So liquidity and yield. We are not a P2P like a model. We are flexible deposit. Suppose someone want to deposit X duration of period, he can anytime he can withdraw. Suppose and actually we are going to use another blockchain here, XRP EVM, which is a sister of XRP Ledger. So what's the advantage of a XRP EVL? We are going to use EVLs, Ethereum blockchains, DeFi protocols, which has huge amount of money or tokens, we can say, funds. In that, suppose for lenders deposit some X amount in Ripple, we are issue tokens on XRP Ledger, and then we can use in DeFi strategies like swapping fee, taking some swapping fee, or like lending things. And our major currency, our protocol's major currency will be RLUSDT, which is stable compared to other currency, and it is easily acceptable by many protocols. So how can we generate the revenue? First is, suppose someone didn't pay any his credit bill, so we are going to impose late penalties. And second thing, every transaction there is a cut of small amount for that goes to insurance pool. That can help. Suppose someone defaults on the loan, so we can cover from the insurance pool. And this is lending spreads, and this is like from the DeFi protocols. AMMPs means swapping sub tokens, and we are going to also offer AMM swaps. On that, suppose someone swap something, so we can get a trading fee. We are also going to partner with some card network companies like MasterCard or Visa that can offer also rewards or loans. Okay. Okay, all right. Yeah. So our ecosystem consumes borrowers, which is which are the unsecure card users, liquidity providers. They are going to deposit on RLUSDT, any protocol that are. So for the current scenario, for the demo purpose, current our settlement lending or yield distribution is on-chain, and credit scoring logging is off-chain due to there is no smart contract in Ripple XRP Ledger. So in future they are going to add smart contract feature in Ledger. So we will shift from off-chain to on-chain, fully logic of credit scoring. That's technology. One more thing is XRP, where our core technology Ripple, and its sites in EVM, and also we are going to, for offering secure credit card, we yeah.
Credit score.
Oh,
Correct?
yeah. That's I want to say.
Do you have that slide?
Yeah, wait a minute. Yeah, this one.
Where is the algorithm here?
We are using similar model like a FICO model. And currently it's off-chain. That I want to say. In future we are going to.
This could be done by क्या बोलते हैं? How XRP is helping you to do beyond current practices? That was the question.
Current credit bureaus are not like transparent. Here everything is transparent, everything recorded on blockchain. So on that basis we can easily calculate someone's score.
Correct.
Yeah.
Your approach is you stake your tokens or currency, then you lend.
Yeah.
Correct.
Yeah.
So you can lend to yourself, or you can lend to your family members.
No,
they return, then you lend them again. They return, you lend them again, and their credit score shoots up.
Okay.
But will I trust such a credit score?
So we are issuing credit line, but it can't be transferred to anyone. We are issuing cards. So cards only used on merchant transaction, not transferring some amount to X person. And for the suppose
stop somebody from being a merchant. A merchant can also collude with the malicious user.
Yeah, they are actually. One more plan is to integrate a Vault ID.
No, not interested in plan.
Yeah.
We had a specific question to you last time. That was the suggestion. Do you have 2 examples? One example was requested. How does the score gets improved? Another example was how does the score gets reduced? Do you have those 2?
Okay. First one for increasing the credit score. It's already we are using similar model like this FICO model, and its code logic also similar. So it based on some metadata like repayments, its credit history, and again its repayment on time, consistency.
You see,
that's similar.
When you have a public or semi-public ledger like blockchain, you have something more than traditional databases. Okay? If I have defaulted and if you are my friend, then my default should have some implication or some shadow on my immediate neighborhood.
Yeah.
Very marginally.
Okay.
With that could be a decision by the lender.
Yeah.
Okay. So if and such a connection is possible on only on ledgers.
Yeah.
So I was expecting from you that you will show us an example that why being on XRPL you have a unique advantage over distributed CBIL.
Okay. First thing I want to say is transparency. That is, and yeah, this is decentralized. Anyone can access.
We all agree on that. So maybe you can show us the final conclusion.
Okay, so that's it. It will globally be accelerate financial inclusion and crypto native empowerment, and it generates APY.
So your demo is not on the cloud,
Yeah,
right?
demo is ready.
On the laptop. Okay, we'll see it later.
Okay, I
Okay.
will show you.
Thank you. Let's thank the contender. So we have the next team online.
Hello, hi.
Hi. So you can share your screen.
Okay. Can you see my screen now?
Not yet. Connect karo lage. Okay, just a minute. Let me connect my computer to mirror your screen.
Lina, your screen is not full screen here.
Okay.
Okay, we are ready.
Now it's okay?
Yes. Infinite.
Okay.
Yeah. We're seeing it now. Good.
Okay.
Nina, it's not full screen. Oh, okay.
Yes. Now it is full screen. You can start.
Okay.
Hi. Can you hear me? Sorry.
Oh, yeah.
Okay. Hi, everyone. Thank you for taking the time to join us today. We are Team Tron Masters, and we are here to present AeroCarbon, our XRP-based free-flow carbon market platform. And before we, Nina, I think you should change the slides.
We want to introduce our team and team members and our project. First, we are the team from the US, and we are students in the first year of master's program. This is our program is AeroCarbon. Sorry.
Okay. And so before we sharing our solution, we wanted to understand the main challenges in today's carbon markets. What we observe is that the market is quite fragmented with registries and standards operating in separate systems, and liquidity is also limited. So executing larger trades can be very difficult. Information isn't always easy to verify, and important data often sit across legacy platforms, which makes audit slow. We realize that these challenges make carbon credits hard to use, especially for enterprises wanting transparency and reliability. And our goal is not to re-event carbon credits, but simply to help them move more freely. And our approach here is quite straightforward. We are not changing how credits are created. We are just trying to make them easier to use by putting key information on chain, connecting participants, and linking certified credit to XRPL. Our goal is simply to make the market more transparent, liquid, and easier to operate. And before explaining what our platform does, we felt it was important to first look at the life cycle of a carbon credit. A credit begins with certification, which happens entirely off-chain through standards like Vera or Gold standard. Once verified, the project data is brought on-chain and maintained as one-to-one backend tokens. These tokens can then be traced through mechanisms such as automated market making, token baskets, or simply futures. And finally, when the company retires a credit, the token is burned and then offset is recorded transparently on chain. Together, these steps give us a clear view of the full value chain. And based on this life cycle, we had to decide which part we should focus on. We concentrate on areas where we believe we can make a practical contribution: on-chain metadata, custody, backend maintain, transparent trading, retirement, and traceability. And we intentionally leave things like certification, ESG assessments, and legal custody to the organizations that are specialized in those roles. Our goal is simply to support the ecosystem, not to replace them. And with our scope now defined, we would like to give a clear picture of how a user actually interacts with our platform, and my teammates will walk through this demo step by step. Nina, I think you mute yourself. I can't hear your voice.
Nina, can you send me
okay,
the
sorry.
link?
Sorry.
Nina, can you send me
okay.
the link? Let me share my screen and let me demo this.
Okay.
Okay. Yeah, just a moment.
Just a moment.
Nina,
Hey.
send me the screen. Send me the link.
Yeah, I send
Okay.
it.
Yes. Okay. Just a moment. Yep. Okay. Hi, everyone. Can you see my screen here? Okay.
Yeah.
So here's our project. This project is so-called Air and Carbon, and which to tokenize the real asset, which is so-called carbon. And within our system, we have a marketplace here, and which will include the project tokens. So the project tokens were issued by the issuers here. So each issuers, they should have the physically permission or authorized by the specific domestic countries. So every country, they will have the authorized to issue the token here. So if the token was issued in the project token here, then the companies or the traders, they can deposit their carbon tokens into the chain, or they can trade into the chain. So firstly, assume that if I were the company, then I I want to trade, I want to buy more carbon tokens. So I will trade here. So within this page, so there is a chance here, which is the price in the past maybe past few days or few years or few months, to see what is the price of the chance. And after that, if I connect to my SRPL, I will skip the testnet. If I connect to SRPL, then I'm going to buy or sell the tokens, while the AMM policy within SRPL, which is provided by SRP chain. So I can buy a lot or I can sell a lot. It's already automatic market making by SRPL. And we also, that is the decentralized exchange. So we also provide another limit order here, which will bring up a new order book here to help us to help the traders, to help the company or the traders to know how much size, how much volume, or what is the liquidity of these symbols. So as you know, if we want to trade, so it means we need to have sufficient liquidity within the market, right? So we also provide another function which is so-called deposit. So if I were the company, I click deposit button here, then I will come to the dashboard of this company. So and I'm gonna do tokenize my real world assets, right? So I will click the tokenize real asset button here to select a specific chain which is corresponding to the previous project type, and I also will key in my project name, and also when will my carbon be expired and what is the size of it. Then I also will upload my personal verification data here, which will be uploaded to which will be uploaded to IPFS, so such as like this. Okay, so after that I can okay, I can click the submit tokenizer request, and this request it will be sent to the issuer portal. So yep. So assume that was another issuer here, right? So I will see the approval list here, which is I just submitted, right? So actually this document need to be verified offline. So it means that actually we will be partnership with a lot of localized company which were authorized to verify the tokens, the real world assets. We are not the person to verify that because we don't have sufficient manpower to do so. So we will check our partners and we will let them to approve and mint the specific symbol coins. And after that, the corresponding account, they will have the coins. They just mine. Yep, should be here. Sorry, should be here. Equity. Yep. So what's yes?
In the bottom, yeah.
Yeah. Okay. So it will be issued. Yeah. And yeah, as you can see, we will once we trade some kind of the chain, right? We will also have the total assets that we have. There will be a list here, and since we are the company, right? So we also need to use this kind of carbon credit. So we can click the retire button here, and we can select how much amount of carbon credit that we want to retire. So once we click the retire button, then we are going to okay. Then we are going to receive a okay. We should be able to receive the PDF here. Yeah. So this PDF can be okay. This PDF can be traded offline. So it means that the company we are, then we can go to the offline and contact our agents to charge this carbon into our account. Then we can use it.
Sorry, John. You actually can click the PDF to show the judges like what PDF looks like.
Okay, I see. Okay. So we also there will be a QR code here that can be scanned by the localized device that we're planning to do. Then we will bring out another IoT machine, which is suggested by the previous run of the presentations. So we're going to bring out another localized devices that help the company, help the auditor, the issuer, sorry, to issue to retire the carbon to the specific company. And as you all know, right? So carbon credit is a kind of non very illiquid symbols, right? Illiquid assets. So it means if we want to have if we want to hedge the risk, if we want to handle the risk that we have, or if we want to such as some kind of company, they're going to use the carbon credit in 6 months later, right? So it is not sufficient for them to trade with the spot strategy. So we put out another future contract here. So we also have the token basket here. Yeah, the token basket is a kind of portfolio. So it means that we can have multiple assets within one bucket to help us to gather as much as possible we can. And the future here is to have the leverage for the retail users. So for the retail users, actually it's just similar with what Binance have. Yeah. So for this is for the retail users to trade for the to bring up more how to say, to bring up more funds into this kind of product, carbon credit product, to help us to build another kind of options product in the future, to help the real company to trade, to hedge the risk in the future. For example, if they want to have the 6 months later future or 6 months later options, that we can bring another kind of structural product here. This is the general idea for the marketplace, and we also have the we also can munch new asset here. So it means if you are the issuers within our portal, then you can enable your permission here to bring up new. I mean, since across the country there are a lot of standards with the localized policy or localized rules, so we need to bring out as much as partners that we can to our chain. So we will have the function here to have new tokens here, and we also.
So are you the?
And sorry. So we also can stop this kind of chain as an emergency suspend. Then it will be immediately appear on the marketplace. Yeah. So also we are providing the custodian features to the users that want to go through that much, and since the transparency for the chains is very important, right? So we will also have another kind of regulatory audit report here to help the users, help the companies or help the auditors to look out all the chain records when they're trading in the systems. And okay, so once more, since we just mentioned we will have the QR code here, right? So if you are the issuers, then you can click the scan button here to upload the QR code. Then we will automatically help you to audit the real data here. Yeah. Let me think whether I missed anything. Oh, okay. One more thing. One more thing is that actually we need to do the due diligence of all the companies when they're onboarded. So we will have another kind of register function, which is not exist here, but we will have the due diligence functions which is powered by Gemini, and so it means that when you register, you need to provide sufficient company materials, and we will leverage our AI prompts to check across the real company data to help us to accelerate the audit progress. And for the issuers also is the same. We will together apply the same rules but different agents to help us to review all the materials provided by the auditors. The issuers. Yeah. Okay. So the token basket, it is a kind of portfolio I just mentioned. And once you trade with futures, you also will have the future position here. you can close or charge your deposit to avoid liquidated. Yeah. Okay, so I will hand over back to. So I'll pause a bit here in case there are any questions. Otherwise, I will hand over back to my teammate to continue the PPT.
Hey, hi John.
Yes, I'm here.
Yeah, so this is Rahul. I have a couple of questions.
Okay.
So two of them based on liquidity, and one of them is for compliance.
Mm-hmm.
So can you share your screen again, the demo?
Oh, okay, sure. Yep.
Yeah.
Here you go.
Okay, so whenever a company or an entity issues an asset, so the price is defined by initially the deposits the company makes, or maybe the liquidity they create. So do you have any other options to, like, they can add on more liquidity, and is it provided an option to any third party market makers?
Good question. Understand your point. So yeah. So firstly, we bring up two functions here. The first function is the AMM function, which is provided by auto market making provided by SRPL. They have a kind of programmatic algorithm to help us to control the market price. That is the one. And another thing is that actually, if we want the market maker to help us to control the price, then we need to, I think, once the issuer they issue the coins to the chain, they need to keep a specific volume of funds to the market maker. Then the market maker can help us to control the spread, control the price, and also help us to provide the liquidity. That is second options, which is from the issuer side. And on the other side is the liquidity provided by the company. So actually, the company they're holding large amount of assets. So for example, for the normal retail users, maybe they just has 0.102 size of symbols, right? That's not that much. That won't impact the price a lot. So, but the company, they will have tons of credits, maybe thousands, maybe 100,000, or maybe millions coins. They're going to trade as much as possible. So those companies, they will impact the prices a lot. So currently, we are not provided the algorithms such as Iceberg or T-Walk, V-Walk function here. So I think at this moment we cannot let them to trade in the system immediately. Otherwise, the price will be increasing incredibly and dramatically fall down. So that's not a good idea. So for us is that we are going to provide the limit price in the centralized centralized exchange we are provided. So the company, they can have a limit price here, and they're not going to impact the market a lot. But I think in the future we will definitely have the pivot wave function here to avoid the impact of the market. So the last thing is that because we are combined by the centralized exchange and decentralized exchange, so I think definitely there will be another liquidity bot, LP bot, help us to transfer the liquidity from the on-chain to off-chain, or transfer from off-chain to on-chain. That is the one that we can have external market maker help us to do so, or we also can do it by ourselves, but it depends on our funds. Yeah, that's to answer your first question regarding the liquidity.
Yeah, it does actually.
Sorry, I think Nina also wants to say something about liquidity problem.
Just let me add one more thing.
Tokenized bucket, right?
Yeah. I want to mention the tokenized bucket here. As you can see, we have the token basket, and that is a mechanism that our platform provides the liquidity for carbon credit tokens. If we are, let's see, let's connect my wallet. Just skip. And you can see we have some basic carbon credit tokens here. And if we want to change it into a very standard kind of token, we can mint it into the token basket like this. For example, I'll put 50 of the token into the basket and make it a standard token. And then this is a mechanism just like the exchange traded funds in the real world. So we built this kind of basket to provide more liquidity for the user on the platform so that they can transfer any kind of basic token as long as it meets the standard in one specific basket. For example, this basket is only for Vedra Golden Standard credits, and later than 2018 can be deposited into this fund. So there is also a mechanism that we provide liquidity to the platform.
And the token minted from this basket is automatically added to the AMMs and the KEX, both of them.
Sorry. Sorry, come again.
Now, I was asking the question that the token minted from this basket is paired automatically and added to the AMM pools so that it can be tradable, and or does it like added to both of them, centralized exchange as well?
Okay. Let me take this question. If you don't mind.
Okay, sure.
So firstly, we are minting the coins here, right? If I'm not wrong. Yeah. We are minting the coins, so it will be deposited into the specific user's wallet. It's not traded yet. So only when the funds will place the orders on the centralized market data, that it will be appear on the exchange. And another thing is that they also can place the order while the auto MM. But at this moment, it was not transferred to AM yet. Okay, does that answer your question?
Yeah, it does.
Okay, thanks. What about another question regarding the components?
Yes, so regarding that, so when a company is onboarded on your platform, so there are some government regulation implications applied to any company when they are issuing a token, and specifically for carbon tokens. And it can be anything depending upon the region. It can be anything depending upon the size or how they operate. So when they are onboarded, you said you are doing the due diligence through Gemini and your own, offline checks. So the implication does lies on you as a platform as well. Like, how are you managing the compliance overall?
Okay, I see.
Actually, we have three barriers to guaranteeing that the token issued on our line and traded on our line is real asset in the world. I think maybe the PowerPoint shows our trading integrity. So maybe we are going to pass to this to Zhang Zhe.
Yeah, actually, I think John missed like 2 more slides. Maybe we should back to our slide and try to explain integrity this part. So.
Okay, let me share my PowerPoint again.
Okay, cool.
Yes, Prof, you can ask the question.
Yes.
You are muted.
I have 2 questions. First one is a very basic question. If you treat carbon credit as a classical currency in a AMM, this would defeat the purpose because it would lead to like gas pricing and bribing the miner. Okay? So it's very important for you to construct an invariant function for the AMM so that the objective of the carbon credit is preserved. I guess this is what even the previous question had, something like a compliance. That is the first question. The second question is, in the XRPL, arbitrage is possible because you see that from one here to here. So if I start from the beginning, I can actually gain credit without losing anything. How would you overcome that?
Okay, good question. I understand your point. So firstly, let me answer your question: how to avoid the arbitrage. So firstly, actually, we are going to bring another LP bot. So it means that actually we should be the person to control the price across the AMM and our centralized market data. Actually, it is not quite easy to maintain two different strategy, because it's quite easy for the normal trader users or arbitrators to take the profit and we will be lost. So, but why we are gonna to have this kind of thing is because it is because we are gonna to bring out others options, structured products and the future products to help the companies to have more possibility to hedge their risk. But I agree that there will be some risks of the AMM that will be arbitraged by the bot. So here is very important for us to design the trade strategy and the contract that across the AMM and order book. So we are still figuring out how to avoid this, and also quite thanks for your suggestion that there will be a risk to be arbitraged.
And the second question of arbitrage, a
Okay.
person without spending carbon credit, he can go on accumulating. This is the arbitrage which is possible in the context of XRPL network. How would you overcome that? Actually, you will be pumping more carbon and you get in and you can go on spending.
Okay.
It is just like, to give you an example what I am saying.
Yeah,
if it
sure.
is a
Thanks.
foreign exchange market, if I'm going to sell US dollars, I can sell it and then come back to me by gaining. Let us say, suppose I had $1,000, maybe later I can have $1,050. That means that I gain the carbon credit without even spending. That means that the invariant function for the carbon credit is not going to be served at all.
Okay, cool. I understand your point.
Yeah.
Yeah, that's a good question actually. So firstly, as it was as we are going to bring the funds on chain, so the price will be increased and decreased. That should be quite normal, right? And since yeah, correct me if I'm wrong. Yeah, I'm still trying to figure out the questions, but let me illustrate my idea first. So firstly, if I holding the assets, right? So that means
the reason I just explain. Let me explain. In a XRP network, XRP itself cannot send the currency in XRP. There are many intermediate nodes in which you say this is the where in which I can buy it. And now if you do that, there is an exchange fluctuation, which could be static, dynamic. That's not a important reason. Now, if you go through a cycle, there could be a negative cycle where I would gain. This is the problem that exists in the XRPL network.
Okay. Nina, did you understand this question?
Yeah, I think if a classic thing, if you look at a Bellman-Ford algorithm, you go on taking a directed graph and put the negative numbers. And now if you go back, is there a negative cycle? From there you can see I can gain without any spending. That is the reason you have to look into, maybe you don't have the immediate answer, but look at it kind of a thing or the other. However, remote is this becomes a problem when the number of nodes increase large in our.
Okay.
Okay. Can you have another example? Yeah. Cool. I will try to explain. Sorry. Can you have another example?
You want me another example?
Yes, correct. Thanks.
Yes, see, for example, $1, suppose I'm going to sell it, convert a US dollar into Canadian dollars and Canadian dollar to Swiss francs and then Swiss francs to dollars. And now in the whole process, in the current dynamic stage, because each node is given independently, it may be the case when I'm going to change $1,000 to Canadian dollars to Swiss francs and Swiss francs back to US dollars, because Swiss francs may have gone up and now I will gain back. So now if you use this carbon tokens, what it would mean is that I'm gaining carbon credits just so that I can use it even though the primary function of the carbon credit is not being solved.
Your question
you have to
is,
think about it, however remote it is, you may not have encountered, because unless you consider the XRPL network, how the arbitrage can happen, and now then it becomes easy for you to understand, whereas if you just use it as a pure AIM model, you may not be able to do that, and now that is the basic structure.
Okay.
Just
cool.
the basic understanding of what professor has said right now, I'll give you is like, so for example, I somehow gain the access to the real world asset of any company, either from your platform or from the company directly. So I can just like simply go ahead and create another like decentralized platform, and I can create a different pool. I can offer like less fees. I can offer faster transactions, maybe slightly different bits than your platform. So like what professor has said, there is an arbitrage opportunity where people can misuse it. So the basic question is, does your platform allows a locking mechanism of the tokens and pools not to be reused in the blockchain? Because some company may want it private, even though it's a distributed system, even though it's a public blockchain, but they don't want this token to be tradable in different platform than yours. Then probably they might be able to restrict the arbitrage opportunities. So is it possible in your platform?
Okay, cool. Let me share the screen again. So within our platform, okay, so within our platform, so once the issuers, if they want to, if we want to issue the coins, right? So it means that firstly we need to have the authorization from the specific issuers. And also when they're going to mint the coins, right? It is not a quite easy way for them to mint the coins, because we only provided okay, so for a specific symbol which is holding by SRPR, right? So such as the SLF XRP, right? These coins. For the Swiss coins, actually we are not authorized across others exchange to mine the symbols. So it means that only the specific issuers or the partner that we are working with will have the main power to issue more coins in case the symbol will be resolved, right? That's not a good idea. Actually, I understand your point. So yeah, I agree that we should have more permission control here, and we also need to have more validation here, and we also won't allow others exchange to have the power to issue the coins. Yeah, not quite understand whether I answer all the questions or not.
Yeah, this makes
And
sense. Thanks for the answer, John.
thanks.
Good.
Yeah,
Nice.
thanks, Professor. Thanks, the team members.
Thanks.
Thank you. Thanks for the
So-
suggestions. We will look into our system.
Yeah.
But we also have several more slides. Need to move on. So shall we move on first? And we will have another maybe several minutes to answer your questions.
Yeah, we can you quickly wrap it up, please?
Okay, sure.
Yeah.
Cool.
Okay, let's move on to the slides here. Hi.
Hi,
Yes, we can
you
hear
hear me?
Yeah,
I think this slide is to answer like the judge's question. So, because now we have seen our demo, and so we want to talk about like a very important part behind the system, the integrity. To prevent any form of double counting, we rely on a combination of supply oracles and XRP hooks, which ensure that on-chain supply never exceeds verified off-chain assets. This safeguards automatically reject any minting attempt that doesn't meet the requirement. Also, whenever a credit is minted or retired, a PDF with a QR code is generated, so the action can be verified instantly in a very simple and user-friendly way. So, hope this answers your question.
Yeah, I request you to quickly conclude.
Yep, sure.
Okay.
Yeah, let's move on,
Let's-
Chris. There's another thing waiting. Thanks.
Okay. I think that'll be all we want to introduce because market mechanism we already introduced in our demo. Okay, so that's all for our presentation.
Okay, thank you. So I request you to be stay online. In some time, we are concluding our conference here. You can join remotely, and at the end, we'll announce the outcome of the hackathon. So please stay online.
Okay, thank you.
Okay. So now I request Professor Yuchi to conclude or say a few words about what's next. And also I invite Professor Shyam Sundar to say a few words. We are towards the end of the conference. You want to go up?
Okay, hello everyone. We are almost very close to the end. So we enjoyed 3 days conference here. This year is in India. So actually this BCK will continue to develop with India, Switzerland and Japan as a core country. So next year we are going to held BCK 26 in Japan. This year, BCK 25, Dr. Vishwas Patil is a key person in the organizing committee. So next year, we are Professor Fujihara, Professor Chezana, and Professor Hadofi. He's in Japan, but today 2 professors in this site. So please come, Professor Fujihara and Professor Chezana. They will be a key person of the organizing committee on BCK 26. So please announce the next year's information.
Introduce. Okay, I'm Akihiro Fujihara from Chiba Institute of Technology, Japan. Actually, as Professor Ikeda said, we to announce next blockchain Kaigi is going to be held in Tokyo, and actually at the Tokyo Skytree campus of Chiba Institute of Technology. Thank you. Maybe I create my slides, so I hope you enjoy visually too. This is Mount Fuji, but this is not conference with. But you can maybe if it is. This is a Skytree. Excuse me. What did you say? It's okay. But yeah, it's okay. I think. So this is a Skytree. On the base of Skytree, there is a Tokyo Skytree campus, and yeah, around here, and yeah, as I said, so you can go up to the top of the Skytree during your during the free time in the conference, and if it is clear, you can see the Mount Fuji like this from the Skytree, and also you can enjoy shopping. And actually, Skytree Town campus has its own exhibition site. In this site, we exhibit satellites and robots and AI and Japanese swords, maybe you like. So if you have a time, please visit this exhibit site. All of these are related to my institution. And a short walk from the Skytree campus, you can find this will bring you to the Kaminarimon Gate and the Sensoji Temple. They are very historic, famous Japanese building, and so every year many foreign people visit Japan to see these. So I promise you enjoy the feeling of old Tokyo. Yeah, so we warmly, so we are looking forward to welcoming you next year. So see you next year in Tokyo. Thank you very much. Is it okay?
Okay. Yeah.
Yeah, of course, Professor
Thank you very much, Professor
please.
Fujihara, for showing us conference venue. It will be a fun conference. So, okay, just we can before okay. So please, Professor Cesana, please introduce by yourself briefly and.
My name is Piero Cesana. I'm professor at Kyushu University, so also based in Japan. We are now organizing, putting together the organizing committee for blockchain Kaigi 2026. I will be the publication chair, so probably I will operate a lot behind the scenes. We're looking forward to welcoming all of you in Tokyo next year.
Okay, thank you very much.
Thank you. And shortly, I would like to announce again the call for paper of the proceeding of Blockchain Kaigi 2025. As I said on the first day, we editorial board members kindly invite you to submit your manuscript, which is an extended version of extended abstract you submitted before this conference is held to the, this proceeding. That will be published in JPS conference proceeding series. And yeah, actually yesterday submission website is open, and also on the Blockchain Kaigi's website, maybe I'll show you the website now. Yeah, now, so the website is updated, and please click this call for paper, then you can find this page, and this is formal call for paper. Then you can download the call for paper, and you can see the detail how to submit. So there is a format to for submission of this conference proceeding. So then you click, maybe I've already clicked, this site. So please follow the instruction bureau and prepare the manuscript. Then, as I said, conference, I'm sorry. This is a conference proceedings submission site, and this is also, this using this link, you can go to this submission site. So first of all, you register by clicking here, and then using email address and password you set up in the registration, then log in and submit your paper. Yeah, so please. We really looking forward to your submission. Thank you very much. Is it okay?
Okay, yeah, thank you very much. So, thank you. So please consider to submit your study presented in this conference. So this is
including poster presentations. So
right.
many poster presenters want to
keynote
submit.
speaker, invited speakers, and general oral presenters, and including the poster presenters. Everyone you show your result are welcome to submit the paper. Okay. Well, thank you very much.
Thank you very much. See you next year.
Thank you. So the next announcement would be about the outcome of the hackathon. So allow me to invite Yash on stage, Rahul also, and Naresh. Yeah. And we would like to welcome them with a small gift from IIT Bombay, a bright cup like your bright hoodies. Yeah. Please come on. Professor Virendra, would you like to do the honor, please? Rahul. And Naresh. That is complimentary. Sorry. Yeah. So maybe you would take the announcement. Yeah. Aerocarbon was the project name. Sure, sure.
Hello. All right. So thank you everyone for presenting the projects. Due to the limited presentation this year, we are just going with the third prize, and as discussed internally with Professor, we'll be going with Aerocarbon as third winner. So congrats team for winning that.
Can we request the team to come online?
Yeah.
Oh, hi. Oh, where the team?
We are seeing only N, whether it's a robot or real N, we don't know.
Sorry.
Can we see you?
You mean turn on the camera?
Yeah. Your whole team, or you are on at different locations?
Sure.
Yeah. So you are Nina, and
Yeah.
where is Ben?
And this is Ben, and another teammate of our team is he's not here now.
Okay. Great.
Congratulations.
Congratulations. So Jay is also here. So we are missing Ben.
Yeah,
and one more
Ben
team
is.
member. Okay. So hang on for a minute. We'll have a group photo with you. So may I request all of you to come on stage and have a photo with them?
Thank you.
Yeah. Let's congratulate the winners. So we'll follow up with you about the next steps for your award, etc. Okay? We'll be in touch.
Okay.
Yeah.
Okay. Thank you.
So
Thank you
stay
so much.
for a minute. We are arranging a group photo here. Yeah, quick, please. Babita, you can also come and see whether somebody is left outside. आ जाओ जल्दी आ जाओ. Yes. इधर थोड़ा अपना position छोड़ दो. इधर आ जाओ. है ना? हाँ. So listen to what he is saying. वो देखेगा, वो खुद बोलेगा तो खुद जाओ. ऊपर का लाइट बस है ना? थोड़ा उधर वो लोग है ना ऑनलाइन. या so please come this side. ठीक है. ये लाइट ज़्यादा हो गया?
नहीं.
तो तुम चेयर पे खड़े हो जाओ. Thank you, Nina and the team. So now I hand it over to Professor Shyam Sundar to say a few words and we conclude.
Thank you.
And we'll go for a tea break, okay? So, Professor Shyam Sundar, you are on mute.
Yeah, it's a real pleasure to see even at the end of the third day, that to a Saturday, there was a possibility of a group photograph, and that's indeed a real remarkable thing for all the work that has put in by Vishwas and also Babita supporting kind of a thing or the other. First, let me thank Claudio having faith in having the BCK 2025 in Mumbai, and also Professor Ikeda, who concurred with Professor Claude, and I hope we have actually given some satisfaction for the 3 days. Unfortunately, due to some medical emergency, I could only join on online rather than come physically and invite you, and I hope you had a nice evening yesterday, and I am sure that all the participants would have enjoyed and carried some of the things what one is going on in the area of theory and foundations, and I hope in the next one there will be a reflection of what has happened this year, kind of a thing. First again, let me thank all my colleagues, particularly the center faculty, Professor Shiv Kumar, Professor Sarthak, and in fact, I was very happy to see Professor Virendra Singh, who was always missing and who has been always traveling. I don't know whether he is in Israel or Rome or today or anything. And because he's a PhD from Japan, I was happy to see that he was here, where there was a large gathering of the Japanese participants. Thank you, Virendra, for all the things or the other. First, let me again thank for Vishwas. He has taken a very big load in spite of the various situation in which it is. Thanks to him, and also the Ripplers who have taken the trouble of coming all the way, maybe even 2 days, and supporting us for the second Ripple hackathon kind of a thing. I hope this kind of interaction would build a bridge between across the departments. And again, thank you all participants. Have a nice day, and then thank you.
Thank you, Professor. So we'll see you soon.
Yeah.
Yeah. So
thank you, Vishwas.
Yeah. Yes, sir. So we'll break for tea, and before that, I would like to thank all the support staff also, without whose help we couldn't have done the things that only they know. So thank you. Thank you. Let's go and have tea. Okay.